Testing audio. Okay. Right. During all will start waiting another like 2 3 minutes until students are coming in. Alright, about the audio and video. It's fine, right? Okay, fine. That's what I'm getting now. There were practicals now. Really? Nice to see you again. Oh, yeah, it's not good. Is that? I checked for me, it's doing fine, I think. Thanks, no, I did that in the case. Or else can try in the mic. Let's see. What about now? Ready Browns. What about now? Is there any difference? Thanks. All right, that's that. Results. Oh, I have it. Right. Okay. Online on if you are got these the practicals that we have already discussed, you can click this link that I have pinned in the chat. Right, there are two links pinned. Right, if you are using Telegram, you can get it from Telegram, or else if you don't have Telegram, the track link is from the Google Drive link. Right, go there and you can get it from there. Okay. Right. So about today's plan. Right, our today's plan. First we'll start off with the first experiment we have in electricity, and we'll go through the first four. Right, first four means first one is from that internal resistance thing, then meter bridge, what I doing that, like first. And then in addition to electricity practicals, right? In addition to electricity practicals, there are two other special and significant two practicals that I have planned to discuss, right? And significance means that is the possibility of coming as a question. That's a significance. One is Young's modulus form, right? So if Young's modulus form is coming, that will be replacing question one, right? And the other one is Jaeger's method, surface tension, right? If that is also coming, that will be replacing question one, right? Question analysis here with you. Even though question one is for mechanics and oscillations experiments, right? From properties of matter also, there is a possibility of coming either Young's modulus or Jaeger's as question one, right? Now, after finishing the electricity experiments, right, our plan is to, as last two, my plan is to discuss the Young's modulus and Jaeger's method one as well. Like they are very important ones, and out of those two, also Jaeger's method is that has been never come in errors, right? So it can come anytime. Right, Young's modulus has already come. But Jaeger's method has not yet come in errors, right? So not yet come means there's a possibility of coming up. There's always a possibility of coming it at any given time. Right? There's a possibility of coming in at any given time. Okay. Then in terms of the exam and the other things, now you are just 28 to 28 days from the exam. 28 days from the exam, exactly 4 weeks. Yeah, exactly 4 weeks, 28 days. Right? Exactly 4 weeks. Right? And I think you have your test and those exams are also happening these days, right? So don't miss the exams if exams are happening, right? Without missing, check the exam and check your level. Right, that is very important before you are going to the exam, right? So as well as you are writing papers in the paper class, writing that in the school or school schools in private banking and school knowledge, right? And it's very much similar to exam wise you get in A-levels, right? Because if you are a school candidate, you will be sitting for the exam in the same school, right? And other than that, to understand the level that you face this papers, that is very important as an indication, right? So don't miss any of the exams happening these days, right? Exams of younger age, or provincial papers, some schools are there, and private exams are there. Sometimes you might have already written the third term test by now, right? In some schools, still that is ongoing, but the second exams, exams of money, right? And in terms of night seminars, this will be the last night seminar conducting for your batch, right? And after today, all the things that we have discussed in here will be over, which means really go on the update. I think most they are there. Then that is only just a matter of how you face it, right? So we have around 1 month for the exam. In the first reading, papers we are not here because reading practice till exam right? Okay, let's start. We'll start with the first one. Product experiment one, practical one, experiment one. Right. Right now, determination of internal resistance. Determination of internal resistance. And electromotive force over the determination of internal resistance and electromotive force. Right. Listen. Right. Listen. All the experiment. Now these are simple experiment and this is actually simplest one out of all in electricity. Right. Simple means in terms of the apparatus, in terms of the method we use, right? In terms of everything, this is a simple one. In terms of everything, this is a simple one. Right. So first thing, what we are going to have is, right? We are going to have a dry shell, an electric shell, right? To find EMF, and with that, another resistor, a variable resistor, a voltmeter and a meter. Right? So it is like another area. Only circuit together in now right? The circuit is just like this. The circuit is just like this. Right? We are going to find the electromotive force over there. Right? Then the cell is here. Right? You can change these positions, phases of these ones as you wish. That's totally fine. Right? And a variable resistor must be here with an ammeter and another fixed resistor. Right? This is a fixed resistor. Right? Say R naught. And this is the variable resistor. Say that is R. Ammeter, or it can be a milliammeter as well. Right? There is a switch, say S, and cell ENR. Since we are to measure the potential difference and current passes through the cell, we have to find the voltmeter. Voltmeters are always connected in parallel combination. And since I need to measure the potential difference across the cell, voltmeters should be connected parallel to the cell. Voltmeters should be connected parallel to the cell. Right? Like this. Right? If your connections are clear, doesn't matter how you draw the circuit, right? That doesn't matter because what matters at the end of the day is the connections. The connections, right? Then diagram meter matters, but the connections are there. Connections are there. Right. So basically, this is what we are going to do. Now, as apparatus, you can now see what we need. See, as apparatus, what we need is this. Now, okay, first materials and apparatus is this. Now, materials are here. Right, meter right here. Right, a voltmeter, an ammeter, a fixed resistor, right, and a variable resistor. Right, for this we can use a rheostat and a tap key. Right. So first mention these things as materials and apparatus. Don't write the circuit, don't take out circuit. First mention the materials and apparatus. Mention the materials and apparatus one by one. A dry cell. A dry cell. A dry cell. A millimeter. A millimeter. Right? A voltmeter. A voltmeter. This is a variable resistor. As variable resistor, what we use is rheostat. Right? Rheostat. And usually the range is up to 100. And this is a fixed resistor. That fixed resistor is usually 10 ohms. Right? And we need a tap key. Right? There are reasons to use a tap key or tap key. We'll see. And to connect this circuit, we need connecting wires. Connecting wires. Right. Listen. Oh, yes. What we do is this. Now, after the setup of the circuit, right? After the setup of the circuit, right? We know if this switch is on, there will be a current flow through this loop, right? There will be a current flow through the loop. if this switch is on, if the switch is on, right, the current flows like this. Current flows like this. When we choose the voltmeter, right, it is advised to go with the digital voltmeter for the experiment because when it comes to digital voltmeters, they are resistance is very much high compared to analog voltmeters, right? If we are close to the ideal scenario, right, no current will be drawn to the voltmeter. Otherwise, the part of current is going to be absorbed by the voltmeter, right? That's the error that we have in a voltmeter. Open up the voltmeter and the potentiometer is used current. That's the reason it's a potentiometer, right? The voltmeter used current, we are using voltmeter, right? And we have two types of voltmeters in labs nowadays as analog and the digital ones, right? Both are fine, but digital one is better because when it comes to digital ones, their internal resistance is very high. They are very high compared to analog. Right? When that is very high, that is close to ideal scenario, then no current will be going to this. Right? Otherwise, now, even if you use the analog one, we are going to negate this current. That's a small current. Like a microampere current goes to here. We are going to negate. Right? Now, this is what happens. When a current goes out from a cell, see, when a current goes out from a cell, this is the apparatus and the method now. When the current goes out from the cell, what is the equation of the cell? When current goes out, we have only a single cell. When current goes out from the cell, potential difference equals E minus psi r. Right? Apply the equation here. Now, electromotive force of the considered cell is E. Electromotive force of the considered cell is E. Right? Electromotive force is E. Then minus, say this current is capital line for right. Say this current is capital line. This current is capital line. This current is capital I. Then E minus IR. Right. Now from these variables, right? From these variables, when I change the resistance here, what is going to change from these variables? What about V? Is it a first term is to be a variable or constant? V? Variable. V is a variable. E is a constant. E is a constant for the battery. E is a constant for the battery. I is a variable. I is a variable because when resistance of the circuit changes, current changes. Now what we are changing is the resistance. But when we change the resistance, accordingly, current changes. Right? And similar internal resistance of the cell is a constant. Right? So always when the cell is designed, E and R are constants. When a cell is designed, E and R are constants. Right? Jaeger thing happens that. Right? E and R are the design values. They are design values. That's not that. Then only variables there are I and V. Right? Now when I change the internal, when I change the variable resistor, right? I changes. When I changes accordingly, then the V changes or V changes. Right? Which means my X variable should be I. Only possible X variable here is I. Right? But potential level is going to stand when I changes, only potential changes. Right? The potential is stand back. Then we are going to add this as X variable. See? And V as Y variable. Then equals minus R I plus E. Now the equation is this is our X variable, right? And this is the productive X variable gradient minus mx plus this is going to be a constant. By obtaining minimum of 6 values, right? Between I and V, the shape is I equal minus mx plus V. And from the gradient, we can find internal resistance. Some of the targets are done. And from the intercept, we can get the EMF. Right? Which means if you plot a graph, this is done. Right? And now we graph according to this. Then after finding this, plot the graph. K minimum of 6 values between V and I. V is measured in volts. I is in milliamperes now. Right? I have got a millimeter here. Right? I is in milliamperes. And that is the minus mx plus c. The basic shape is like this. Right? And minimum have 6 values, 6 readings, and plot the graph. and the intercept here is going to be E, and the gradient here is, right, gradient here is R. That's negative gradient is R. Right? So if the graph is what? Both are done. Right, now we have mentioned only the materials, no? Right, then as separators, mention this. Mention this again. Now, always what we have to understand is the connections of the circuit. Understand the connections, right? All the IT series combination except the voltmeter. Voltmeter is a parallel device. Everything else is series combination. And the full series, and these are very potential experiment to come, right? Right. Right, okay, and make your connections clear. And mention this as the theory. Right, after the git, mention this as the theory. When you draw the circuit, it doesn't matter whether your switch is on or off, right? Switch off कर दी पर अंदर वहाँ पर instruction है, नौ रखने हैं. We know that there should be a closed switch. When car close, but when you have drawn the symbol of the circuit, symbol of the switch, right? Symbol is the open area. That's fine. Okay, right? Then mention theory also. And mention below the graph, gradient equals gradient. Gradient, simple length equals R, and intercept C equals E. Right? This one is not a big deal, a simple experiment. But in terms of the potential, right, is a very high potential experiment to come. Okay, finished. Comment. Okay, then let's go to the method. Find out method. 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 Found a method. Write out in point form. First point, write out. Connect all devices. Connect all devices. Connect all devices. Connect all devices. As mentioned in the circuit. 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 And make the variable resistor and make the variable resistor within brackets rheostat and make the variable resistor within brackets rheostat infinity and take voltmeter reading and take voltmeter reading and take voltmeter reading. Listen, that is a precaution. Right, the reason to do that is, right, if this resistance is set to infinity, right, theoretically there should not be a current, right, there should not be a current. If there is no current, then across the voltmeter, what should it measure is, right, we is going to measure E, right. यहाँ भी ये का मेथड चेक करेगा ना करंट क्या होगा नहीं, right, अभी ये one and बड़ी idea है, just to get an idea about it, right, without flowing the current by setting this to infinity. I'm a resistor again, but if you are using a resistor box in boxes, infinite one is there, right? In the rheostat, not in all rheostats, it is available. People, infinite one, not compulsory, but we are just getting an idea what P is going to be just by checking the voltmeter reading before starting. Now, start before starting, right? Now, then only we are going to start. Now, what we do is this, right? Here in this rheostat, we have a range of 0 to 100. Right, we are going to change this value accordingly as we are taking some milliampere readings. So current readings 25 for each 25 milliamperes, right? Milliamperes 25 or 30. ये वाले range है right? To change that accordingly, we are using a rheostat. Then resistor box है तो हम only value को change करना है, but in rheostat we don't have something like that. All the continuous values can be taken, right? Say we are starting from 100 say we are starting from a current of, let's say, 200 milliamperes, right? Then the second reading is around 175, then 150, 125. Unever readings here current, and we are now taking into like two small values as well, two small, two large here values, right? Then, as the next point mentioned, now, decrease R, accordingly, as millimeter reading, changes approximately by, as millimeter reading changes approximately by, 25 to 30, milliamperes. 25 to 30 milliamperes. Right, 25 to 30 milliamperes. Right, yeah, standard tag 25 milliamperes, like 25 to 30 milliamperes. And record the readings of current against potential difference. Current against potential difference given by voltmeter. Current against potential difference given by voltmeter. Right. Now, if you are taking it to a table, the table looks like this. And if you are taking it to a table, the table looks like this. We just need 6 current values, right? We just need 6 current values. Resistor venas karana apne value badanna, right? Resistor venas karana value badanna. That is not ignored in the calculation, right? Our only focus is changing resistance as current drops by 25 milliamperes. That's it, right? Current changes by 25 milliamperes. Resistor venas and what we are recording is only I and R. I and V. What we are recording is only I and V because we don't need potential. Sorry, we don't need resistance. 1, 2, 3, 4, 5, 6, like this. Right? Are we stable? That's all I need. Plot the graph. Plot the graph. Plot the graph. Plot the graph. Between V and I. Between V and I. Plot the graph between V and I. Plot the graph between V and I. As discussed under the area. 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 And determine. And determine. And determine. Simple R and capital E. And determine simple R and capital E. Simple R and capital E. Using gradient and intercept. Using gradient and intercept. Using gradient and intercept of the graph respectively. Using gradient and intercept of the graph respectively. Right. So as the experiment, that's it. But about the experiment, this is not the thing here, right? There are like many more minor details asking about these things. Why that key issues and why another fixed resistor issues, even though I have a variable resistor here, resistors there, right? For now, potential details are. Otherwise, now as the experiment, what we are doing is just this, right? Experiment is very simple, right? Why using a digital voltmeter is better than analog one, right? Right? So these things, right? These things are very much important and very much popularly coming into questions. Coming as questions, I will not, I think experiment again, otherwise, now for the experiment, when this is given, when this experiment is given, around 10 to 12 marks are given, and for other minor details, right? Another significant part will be allocated. That is how the nature of this experiment is, right? Then major remarks. The reason for using a tap key. What are the keys available? What are the keys available? Plug keys and tap keys. Right? Plug keys. Plug keys are the keys that you can switch on by plugging the connector. Plug key again. Plug it down. Once the plug is plugged, the circuit is connected. Right? That is connected, and that is not going to disconnect again unless you take off the plug. Right? Plug is no gonna say. Google plug is once the plug is connected, circuit is on. Right? Tap keys means in tap keys, there's a part like this, and another connector here. You have to tap this, and connect this to the connector here. Right? Tap again, you are tapping. Right? Plug key right? Plug key started at plug key is like this, right? And here we can connect a plug. Once that plug is connected, the circuit is connected, right? And the tap key is like this. In tap key, there's a connector like this, and this is going to connect to here once you tap this. Right, they will tap करना. Once it is tapped only, so it is connected. Once you take hands off, it is automatically disconnected. Right? If you need a constant current over a long period of time, right? Which keys we are using then? If we need a constant current over a long period of time, that keys or plug keys? Plug keys. Right? Then that key can make a say you are doing the experiment for 30 minutes. So 30 minutes make a that there is no convenience in that case. Right? They were the plug keys. Right? If you need an instant current, instant currents. If you need an instant current, we are using tap keys. Right? Tap key and the advantage of using tap keys is, right, we are just pointing the current at the very point that you are taking the reading. Right? And the other times, there is no current passes through the circuit, which means the discharging of the battery, right, or degrading of the battery is minimum. Otherwise, if this key was put on, right, until you are taking all these 6 readings, right, continuously, current flows in the circuit. Right, when current flows, then this battery discharges. Right, battery whatever discharge not pass right, that's why this is used. Then, applicant readings are you have to tap this only at these 6 points that you are going to take the readings. Right? Right? 6 again, 6 or say you are having this for 10 times, that's it. Continuously make the benefit is battery is not going to discharge and degrade. Right? Leesa make a use I battery discharge battery if the battery is degrading, then it changes. Right? Battery discharge it changes. Battery right? Constant that will be constant, right? When we use only. Constant that's why, but tap key is compulsory. Right? Why tap key is used over plug key. Right? Right. First write it down. First point. But tap key is used. A tap key is used. A tap key is used. A tap key is used. If a higher current flows through the circuit, 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 for a longer period of time, but is used if a higher current flows through the circuit for a longer period of time, the battery can be discharged. The battery can be discharged. Within brackets, this can be minimized. This can be minimized. This can be minimized. This can be minimized. When an instant current flows, this can be minimized when an instant current flows. When an instant current flows, this can be minimized when an instant current flows. At the point where readings are even. At the point where readings are even. Right. Listen. Next. Right. Very important. This is about this. Now, even though we have a variable resistor here, with a range from 0 to 100, right? With a range from 0 to 100, we have a resistor here, right? But yet, we are using another fixed resistor, right? Fixed resistor of 10 ohms. Right? The reason is this. Now, when you are decreasing the resistance, right? When you are decreasing the resistance, if it is decreased too much, there is a possibility of passing a higher current through the emitter. If there is a higher current passes through emitter, one means there is a possibility of burning out the emitter. Because galvanometers and ammeters, they are very sensitive instruments. Abhi meter conversion चल रहा है, moving coil meters, right? Galvanometers के लिए क्या है? They are very sensitive. They are very sensitive. But pick up Jaeger plus if a higher current passes, the heat dissipation of the circuit is higher. Right? Because circuit का रास्ता ना, heat dissipation is higher. तो यहाँ पर pattern है unknown heat dissipation है क्या? To avoid those, this mechanism is also used to control the maximum current. To control the maximum current. The main resistance है आप यदि 0 वगैरह पुनः, but still there is an enormous resistor working in the system. Right? That's all. आता अभी रियोस्टेट के मेगा इलेमेंट लगा दी और एक बार 0 0 चा अकाल करंट का फ्लो है ये करंट का मेगा रूबियो या मैक्सिमम मेगा एक्सीड करो. Right? Now expensive, I mean it's not expensive, right? It will be burnt out. Right? Next point. Right? Imagine the current is too much very well, the current cannot be too much high or too much low. Right? If it is too much low, right, there's another problem arises because now we are using an unideal voltmeter. Ideal voltmeters are running. Then there's a small amount of current. There's a small amount of current which passes through the voltmeter also, even though we have neglected. Right? Now we have neglected that microampere current with respect to some milliameter currents. Right? If my current flows in the circuit is also very small, can we neglect it reasonably? For a small value, small value, small value neglect compared to the millimeter values, micro can be neglected. I mean, provided micro current and neglect because the errors are high, or fractional errors are there. Correct? In under too much, I will like 10 of these issues. Right? Some resistors are resistors area, there are 10, 50, 100 these are fixed resistor or suitable resistor as the fixed resistor. Right? 10, 50, 100 resistor. Right? Then you know that the value is 10 is a kind of a average value. 100 the current. Right? When it is dropped, you can't neglect the current close to the voltage. I mean, you can't tell it. Put current and I put current, that's a sensible value. That's how we can neglect it. Right? Next point. Mention. All these points are very important. Next point. Mention. A fixed resistor. A fixed resistor of 10 ohms. A fixed resistor of 10 ohms. A fixed resistor. A fixed resistor of 10 ohms is used to control the maximum current. To control the maximum current. To control the maximum current which flows in the circuit. To control the maximum current which flows in the circuit. For the same point, but this resistor should not be a higher resistor. But this resistor should not be a higher resistor since if current drops drastically, the small amount of current flows through voltmeter. The small amount of current flows through non-ideal voltmeter, flows through non-ideal voltmeter. Cannot be neglected. Cannot be neglected. Cannot be neglected. Cannot be neglected. Right. Next. Right. Now when you are choosing voltmeters, practically, right? Over the analog one, digital one is better because in digital voltmeters always the ranges are high. Since the ranges are high, there are resistance, internal resistance are very high compared to analog ones, right? Higher internal resistance, lesser the current it flows through this, no? Which means lesser the error reading, right? Lesser the error reading, right? Right now, next point. Next point. Using a digital voltmeter, a digital voltmeter is better compared to an analog voltmeter. Using a digital voltmeter is better compared to an analog voltmeter since resistance of digital voltmeters, since resistance means internal resistance of voltmeter, since resistance of digital voltmeter is very high, so it absorbs a very small current. So it absorbs a very small current. Right. Listen, next thing. You will be asked whether using a resistor box is also possible instead of rheostat. Right? Take a variable resistors. Right? We have only two types of variable resistors, two main types of variable resistors in labs. Right? Rheostat and resistor box. Right? 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 Now, if that was asked about this task regarding this, what's the main difference between resistor box and rheostat? What's the main difference? What's the main difference? Rheostat is for continuous values, which means now since the range of rheostat is 0 to 100, which means any value in between 0 and 100 is obtainable using rheostat. Right? Rheostat can have a continuous setting because we are moving the slider down. Rheostat is a slider thing. Right? When you move the slider, then accordingly resistance changes. Right? Then any value from 0 to 100 can be taken for the rheostat. Right? There is one advantage of rheostat, and the other disadvantage as well. Disadvantage is you can't take the reading. You can make reading here or make register or not, but you can't say whether it's 10 ohms, 10.5 ohms, or 5 ohms. You know, that's a disadvantage. And about resistor box, what's the main difference? In resistor box, only discrete values are there. Resistor box ke flux or and in these flux, the values are mentioned. So what you can get is the values that you can get, or the combinations of values that you can get by changing the flux. Right? Flux or values change combinations with so that is called a discrete variable. Discrete continuous discrete and continuous variables. Right? Discrete means, right, only some finite values, right, or given values can be there. When is our resistor box used to we can't obtain any value as we wish. Right? Combinations, right? 1, 2, 3, 4 1, 2, 3, 4 combinations of 1, 2, 3, 4. It was 1, 2, 1, 2, 3 at 6 6 combinations. right? And then combinations will come. That's it. Right? Whatever 6.1, we can't do it. That's it. Right? Now here, the thing is this. We are changing current by 25 milliamperes. Right? Now 25 by 25 change करें. Then to change the current by 25. Do we know the suitable resistance? එහෙම දන්නේ නැහැ. එහෙම කියන්නේ නැහැ. ඉතින් resistor box එකේ resistor value එක change කරලා පස්සේ can we make sure that it's going to change by 25? එහෙම කියන්නේ නැහැ. Right? Make a question because just by looking at or checking at the millimeter reading, you can change this accordingly until your current changes by 25. There are going there. Resistor box again, or make sure that because you can't change the resistance as you wish. Right? That's the thing. Yes, resistor box use right? Resistor box cannot be used because we are changing current in 29 intervals. Right? How many intervals can resistor box used? Okay, next point. Resistor box cannot be used. Resistor box cannot be used. Resistor box cannot be used. Resistor box cannot be used as the variable resistor. Resistor box cannot be used as the variable resistor. Since resistance cannot be changed continuously. Cannot be changed continuously. Cannot be changed continuously. To change current flow. To change current flow. To change current flow continuously. To change current flow continuously by 25 millimeter. By 25 millimeter gaps. By 25 millimeter gaps. Right. Next thing. Now, when you start the experiment, now it takes some time for the thing. For the thing means to take 6 readings. Right. So after taking 6 readings, if we need to make sure whether the battery is discharged, right? Battery discharge check and method explain and we are using the same thing memory technique potentiometer electricity that if we need to make sure whether the battery is discharged. At the end of the experiment, right? What we do is we are taking the initial reading again. Right? Maybe initial value set initial reading right? Once you take the initial reading again, right? We can compare the voltage difference here again with the first reading. Initial value again after finishing everything, after finishing all 6 readings, right? We are changing this back to the initial value and going to take the initial reading again. Initial initial voltage for the initial value of current the initial voltage has been the 2 volts, right? And after finishing the experiment, you are getting it as something like 1.4. They get discharged. And a considerable discharge, then the experiment is unsuccessful. Right? You know, right? If there is like 1.9, 1.95, right? Discharge in the battery already discharge battery use new battery right? If you need to check whether the battery is discharged at the end of the experiment, right? In electricity experiment, what we do is we are retaining the initial read, right? You have to retain the initial read, right? Mention the next point. To check whether battery is discharged at the end of the experiment. To check whether battery is discharged. To check whether battery is discharged at the end of the experiment. To check whether battery is discharged at the end of the experiment. The initial reading is taken again. 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 And the value obtained for B, and the value obtained for B is compared. And value obtained for B is compared. And value obtained for B is compared. Right? Right. From that, you can make sure that the cell is discharged considerably. Right? You have discharge channel. Again, right. So basically, that's it about this. Right. Basically, that's it about this. Let's quickly see what is given here in the guide. So now the circuit dash on the figure, and I just reverse that for the maximum resistance. Again, 100. Right. Decrease the line. So the reading of voltmeter is open and record the value. Next, close the key while increasing the resistance of rheostat and varying the value of I by 25 milliamperes. As a standard, we say 25, right? But it can be varying from 25 to 30. Because out of that 25 to 30, yeah, standard depth there 25. Number of oscillations we counting simple pendulum, right? Pendulum that in helical spring. What's the standard count? We've done a standard counting here. Standard is 20. Standard is 20. Standard is 20. Right? Minimum 20. Okay, then obtain the 11 voltmeter readings along with the milliampere readings. Okay, but yes, because discussion. Discuss the measures taken for the safety of the apparatus. Right? Measure for the safety of the apparatus means this fixing arm node. Right? Discuss discuss. Although the causes of action taken to minimize the errors of the experiment. Right? No, due to large current being drawn, for a long time, dry cell would get polarized and get discharged in a little time. The 10 ohm resistor is used to limit the maximum current. Right? Very important. We make a discharge. Right? Unknowingly. The key helps to flow the current for a short period of time. Right? Instant current. Instant current is not keying in. Right? Tap current. Right? Practical issues. Key current fast in right. The contact is the fast in contact. Right? For the however, the key has to be pressed sufficiently. I mean, either can't do it. And that we can but can be asked because the key is not tapped properly, right? Current is not passing properly. Current is passing, but not the proper current. That is to be passed. For the contact argument, take a pass. Current is the pass. That key has to be pressed sufficiently hard to keep a good contact. Since the internal resistance of digital voltmeter is much higher, the current through it can be neglected, right? You're going to take it. Hence, it is necessary to use a digital voltmeter for accurate measurement for the potential difference of person. Right. Okay, so that's it about the first one. Any questions? Any clarifications? Good. Alright, okay. I check a lot. Just go through what we have done from the beginning and ask if there are anything before we go to the next. The question based training program. Question based training right? And but still that's there. The students Day 19 was the last thing. Day 19, oh, 19. Can I explain again why a turkey is used? Like a here, is it clear? Is it clear about the turkey now? Right? So I need something else to go. All good. Right. Yeah. Right. I did a part of that. Yeah. You got that? Moving. Hey, man, em bảo đi giá giống như kìa. Okay, anything else? Horana. Okay, then let's go on to the second. Okay, right now, it's gonna go. Right now, it's gonna do determination of determination of determination of determination of temperature coefficient of resistivity. Determination of temperature coefficient of resistivity. Temperature coefficient of resistivity. Determination of temperature coefficient of resistivity of a metal using Metre Bridge. Of a metal using Metre Bridge. Se va, ¿no? Again, last thing I did, give it on YouTube. YouTube done that. Otherwise, lesson based and question based. When going on the classes, right? On the video done that. Well, start already. You will see. Let's see. Okay, listen. 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 I think there's a same. First, I'm going to do the apparatus. About the apparatus, right? About meter bridges and potentiometers, you will be able to draw them, right? Mostly when it comes to questions, right? How you are getting this is an incomplete diagram will be given, and you have to connect other connections with the other missing instruments, missing devices, right? You know anything, but to do it properly, you should be able to draw these, especially meter bridges and the potentiometers, right? അതിന്റെ പ്രോഗ്രാമിന്റെ കൂടെ if you are drawing the meter bridge, you can get if you are drawing the meter bridge, right? Starting from the copper strips, right? Basic idea, start the meter bridge from the copper strips, right? Copper strips not beyond, starting from the copper strips, like this. That is easier in your draw, right? In the practice, incomplete diagram समझिए अरे ये अरे प्रैक्टिस में लगता है डायग्राम में कंप्लीट कराना पहले right steps then the main part here meter bridge wire Right, main part here which is Metre Bridge wire. Metre Bridge wire wire goes from here to here. Right. Right. Doesn't and when you connect this setup, right? When you connect this setup, doesn't matter whether you are connecting the modified apparatus to this side or that side. Yeah, main software දාන්න පුළුවන්, base software දාන්න පුළුවන්. Totally fine. connect කරලා ඉන්න පුළුවන්. Right? කැමති විදිහට දාන්න මම මේක space එක ගියාද නිසා ඒක දෙනවා. Right? Otherwise that doesn't matter. Right? And medium. Make connection is yours. Listen. Accumulator. Right? Accumulator. Switch and the variable resistor. Right? And here there is a fixed resistor and non-resistor, a fixed resistor, a non-one, and the same thing which we have in potentiometer, meter bridge, right? About the galvanometers, like say galvanometer, safeguard resistor, plug key, everything is same. Finally, everything is same here, right? Take everything. Connections are nothing. Yeah, a safeguard resistor, center zero galvanometer with the slider key. And to short circuit the safeguard resistor, we have to have another plug key parallel to the safeguard resistor. Right? Same resistor that is also called safeguard resistor of center zero galvanometer. Right now, our band is this one. Our band is finding temperature coefficient of resistivity. Temperature coefficient of resistivity. Right? Right? Temperature coefficient of resistivity. Right? That is alpha. There is only one equation we have alpha in the syllabus. What is the equation? R equals R naught 1 plus alpha theta. Right? If one resistance is known R theta is resistance at 0 degrees Celsius. To change the resistance, right? We are using a copper wire here. To change the resistance by increasing temperature. One equation I expect by doing this. R theta equals R naught 1 plus alpha theta. This is the only equation we have with alpha. Right? For a conductor, R theta equals R naught 1 plus alpha theta. If there is a semiconductor, that is 1 minus alpha theta. Right? For insulators, no equation. Insulators are the equation stand. Right? For conductors, 1 plus, for semiconductors, 1 minus. Right? Conductors, come equation. Then, to change the resistance, right? We are modifying the meter bridge. Now, usually in the meter bridge, what we have is two resistors in these two also, right? Because usually we use the meter bridge to find an unknown resistor, right? Unknown resistor එකක් වන්න තමයි meter bridge එකේ අර prime purpose එක to find unknown resistor, right? ඒතර මෙතන unknown resistor එකක් ගන්නකොට ඒක වන්න පුළුවන්. Now, since I need to change the temperature of the resistor accordingly, right? The setup is modified with that focus, with that tower, right? Make the temperature වෙනස් කරගන්න ඕනේ. එහෙම වෙන්න තමයි මේ setup එක හදන්නේ. Then to change the temperature, what we do is this, right? When you heat a metal wire, right? A copper wire, material copper කියලා when you heat a copper wire, right? We can't make sure that entire wire is heated if you just heat it by using a flame. No? Bunsen flame making flame. Then what we do is we are going to dip this, immerse this inside a liquid, right? Usually coconut oil is used, right? Coconut oil use करना, coconut oil वगैरह डाला, मैं करना, and we are going to wrap this around an insulator like this. Insulator है like piece of wood, this layer, and this is wrapped. मैं wrap करना, मैं wrap करना भी लगे ने, मैं wrap करना like this, the wire, and is connected to this one, and this wire is connected to this one. This is filled with something like coconut oil, right? There are reasons to use coconut oil, right? Coconut oil are reasons here, right? And we have to heat this now. You have to change the temperature. To change the temperature, this is kept on a stand tripod, and the burner is used. To measure the temperature, right, we need a thermometer, and to make sure this is distributed uniformly throughout the volume, right, we have a stir, then the stir is used, right? When we modification and the wire that you are going to, which you are going to find the alpha is here, right? The wire is here, right? That wire is here. Then pass connecting wire switch on now. Method copper wire, right? So basically, what we are going to do is this. We know when temperature changes, accordingly, resistance changes. Like what is R theta? Resistance at theta degree Celsius or Kelvin. Degree Celsius only. The equation chemically use that, right? The chemically use that, right? R theta means theta. Theta theta is the standard symbol for temperature. Standard symbol of Kelvin temperature is capital T, right? Capital T. So, body sensor that's why those symbols are right. R theta. Temperature at theta degrees Celsius. R not temperature at 0 degrees Celsius. Not 0 Kelvin, 0 degrees Celsius. Right? Main equation is Celsius. Then alpha temperature coefficient of resistivity. Right? Theta temperature or temperature difference. Present temperature. Only present temperature. Right? Thermal equations are temperature difference. Why? We have the 0 degrees Celsius here. Difference is nothing. We are going to take the difference with 0. Where difference that is present temperature or the current temperature. Right? First level. Make an equation. Now, from the equation, now R theta is known. R naught alpha theta. About the Metre Bridge. By the way, what is the principle of Metre Bridge? If you ask about the principal used in a Metre Bridge, what would you answer? 28 days. Principal used in a Metre Bridge. What then? Online, what's the principal used in a Metre Bridge? Online, what is the principal used in a Metre Bridge? Why? It's a principle, right? It's a principle, right? It's a name. What are the it's a right? Yeah. See, what you are doing is listen. What we are doing is after connecting the old graph, right? Have to find the balance point of so at standard rotations. Positive terminal of which is called A, negative terminal is called B, right? And balance point is called C, right? At the balance point, there is no current flows to galvanometer, right? If there is no current flows to galvanometer, which means potential at these 2 points are equal. If no current flows to this branch, right? If no current flows to the galvanometer, right? Which means, according to Wilson principle, right? According to Wilson principle, right? Because principle of Metre Bridge is Wilson. Alright, because there are no current flows. Now in that case, we have a galvanometer, right? So these can be between A and B, and these points are X and Y. They are R1, R2, R3, and R4, right? If R1 over R2 equals R3 over R4, then Vx equals Vy. This is called Wilson principle, right? This is called Wilson principle. Now in this case, what happens is, if there are no current flows to this, right? Which means these resistors, whether they are resistor and this one, and there are resistors for the Metre Bridge wire, for the length AC, right? And these are other resistors, they are known. So these are known. R dash of India, R dash, there is a non-fixed resistor, and there is a resistor for the length CD of Metre Bridge wire, right? When you know the resistors are 1, 2, 3, 4. If there is no current flows to here, it satisfies the ratio, right? Okay, then when you apply this is proved, the equation proved in a Metre Bridge, right? Let's say this resistance is now R theta, right? R theta, then R theta over, say balance length is L, right? If this length is L, this side becomes 100 minus L, right? Then this one to this R theta to L equals R dash to 100 minus L, right? Now, likewise, using the meter bridge, you can find the resistance at a given temperature. Using the meter bridge, you can find the resistance at a given temperature. Say you are starting from 25 degrees Celsius, right? We are starting from 25 degrees Celsius. Then at 25 degrees Celsius, after connecting everything, right? Balancing flame, balance flame right? Controlling flame, they are current loading. They are also valid because now when you are taking the reading, always you have to make sure that there is at that constant temperature, 25 reading the current loader, right? Or the system 27 that's not the case, right? You are control. They got experiment. Right? They got control. Right? Then say you are starting at 25 or 25, they are the because L is around there, R dash is around resistor, right? Then once you apply this in the equation, R theta is known, right? The R theta is known. We can connect these two, and find alpha using this, right? When we are we have to plot it out by minimum of 6 values, right? Then meter bridge is used to find the resistance of this wire at different temperatures, right? meter bridge use kare. Equation hai equation hai feed karane using this. This is the meter bridge, right? Hi. Then now from this subject R theta, R theta is given by R dash L over 100 minus L. R dash L over 100 minus L. Now, if we connect these two, R theta is this no R dash L over 100 minus L, right? Equals R naught plus R naught alpha theta. Now, what are we changing here as the independent variable? What are we changing here? What change kar? Temperature, right? When temperature changes accordingly, what the change will in the equation? When the equation we have a equation. R dash constant variable. R dash is a constant. Constant. R dash is a constant. L is a variable, right? R naught constant. 0 degree show resistance right? And again, over constant. Characterize the given temperature coefficient of ice field. That's the constant. Theta is a variable, and that is what we can change manually. But after change, then theta is going to be our x variable. When theta changes, L changes, right? Always to find or to determine gradients, right? We prefer linear graphs. Linear graph is gradient easily curve gradient because use last week use then always will be prioritizing straight line graphs, right? To plot a straight line, to get a straight line, right? We are going to take this whole thing L over 100 minus L to the axis y and go to this, right? And then L over 100 minus L is here. Then this is R naught alpha over R dash times theta plus R naught over R dash. Right. Now this is x. This whole thing is gradient, and this is intercept. This whole thing is y, and the graph you are going to get it y plus mx plus c. Right. This is L over 100 minus L. Right. And this is theta. Theta is in degrees Celsius. L over 100 minus L. Right. L over 100 minus L. What's the unit here? L over 100 minus L. No units, right? Then no units, right? Mx plus c. And I'm going to mx plus c. And now the intercept is Result is R naught over R dash. And gradient is R naught alpha over R dash. Then how we can find alpha? The graph then the 6 readings are here, graph and then moment under the right? What's the easiest way to find the coefficient, temperature coefficient? Alpha go using gradient. No. Why? Gradient on where? Because R naught is unknown. Because R naught is unknown. Even when R naught is known, we don't go to that option. Right? My column here. Because when we have cancelable variables, right? Always our first priority is cancelling those variables. Right? That's R naught take one kilometer, take 1 kilometer, that is coming into values. Right? Say we know R dash what the none. Right, even though this is my known resistor, none of them they are just right? If you divide gradient by intercept, right? All R naught and R dash both are going to cancel off. Then no error in the calculation. Right? अबे हमें लेगा R dash करना. Right? हमें लेगा check करना तो this is not only limited to this experiment. Right? लेगा बड़ा क्या कर दिया? Right? बड़ा क्या कर दिया? And electricity potentiometer වලත් තියෙනවා මේ තව අනිත් ඒවාත් තියෙනවා මොනවාද ඒක පුළුවන් that's the thing හරි හැම වෙලේම gradient intercept එකම check කරන්න if you are getting the value by dividing gradient or intercept right always our priority is that right gradient එකේ තියෙන unknown variables ගන්න යන්න නැහැ okay then we need alpha is given by gradient over intercept is alpha right so likewise we can find that. Right, so as an experiment, this is part of a what we call a lengthier one, right? A lengthier one in terms of the details and also in terms of the time it takes to do it. Also, this is part of a lengthier one, right? We didn't write anything yet, right? No. Okay, first write down materials. A copper wire. If that is insulated, that is better. If that is insulated, that is better. Right? A copper wire. Right? Make the body SWG. What is SWG? What is SWG? Body SWG. What is SWG? एक रात ही ना पहले क्या करना 40 SWG किया then लिख लो SWG means standard wire gauge तब मैं देख अभी वायरिंग करना है इलेक्ट्रिशियंस है मैं standard wire gauge 40 के लिए क्या है मैं वायर से मैं वायरिंग किया वायर अन्य SWG standard wire gauge 40. Right, okay, so sizes there and 40 kilogram, okay, diameter area value 0.04 diameter area. एक conductor number कोई दी, right? वही अभी households wiring या wire लगा दिया ना ये, अरे मैं wire roll लगा दिया मैं तो आए कोल बार ने ना इधर से अरे neutral base and wires एक अलुबाड़ी मगे ना था यार मैं ये लगे ना वो एक है दिया ना ඒක කැපුවට පස්සේ ඇතුලේ තියෙන කොපා වයර් එකක් තියෙනව නේද? දැන් ඩැගල් නැත්තම් ගෙදර ගිහලා වයර් එකක් ගාලා බලන්න වෙනවා. දැන් ඔක පාන්න ඕනේ. නැත්තම් පොයින්ට් එකට එකක් බලන්න ඕනේ. අන්නේ වයර් එකේ ඒක තමයි WG එක කියන්නේ ස්ටෑන්ඩඩ් වයර් ගේජ් එක 40 කියන එක කියන්නේ ඒක 40 කියලා කියන්නේ. මේ තරතල ලියලා this is called standard wire gauge. නිකන් දැනගෙන ඉන්න මේක SWG කියලා මේකේ දාලා තියෙන නිසා මේක දැනන්නේ standard wire gauge. Standard wire gauge. Right? Then an accumulator of EMF 2 volts, an accumulator of EMF 2 volts, an accumulator of EMF 2 volts. Right? Negative of Metre calculator this is Center 0 galvanometer. Right. Next, write down center 0 galvanometer. Center 0 galvanometer. Slide again. Slide again. මේ keys මොනවද කියලා මම කිව්වා. Say these keys are external to what keys are those? Plug the tap the. Huh? Plug the plug keys. Right? Two plug keys. Two plug keys. දැන් මේකෙන් තව වගේම කම්පෙයාර් කරන්න ඉස්සරහට කියන්න ඕනේ. මයි plug keys are used කියන එක. Right? Two plug keys. Two plug keys. Right? Because a resistor box. A resistor box එක මේක මේ and rheostat. A resistor box and rheostat. Even though you use a rheostat, sorry, or a resistor box, right? මේක වෙනස් කරන්න යන is a fixed resistor, right? මේක fixed, මේක fixed until you are doing these things, right? So a resistor box and a rheostat. Then Bunsen burner, tripod, thermometer, styler, maybe a polygon. Right? Then meter bridge setup. Meter bridge setup කියලා කියන්නේ මෙන්න මේ part එක. Meter bridge setup means right නේද? meter bridge එකේ තියෙන්නේ board එක right? With all three strings and the meter bridge wire. Right? මෙන්න මේ part එක තමයි meter bridge එකේ තියෙන්නේ. මෙන්න මේ part එක. මෙන්න මේක විතරයි. Right? And මේක නෑ. And everything else you need to set up. Right? You got to set up and then there you can start the experiment. ඒක as a whole you can't take it. Right? 0 galvanometer අරගෙන resistor දාගෙන හරි ඊට පස්සේ මේ key side දාගෙන ආන එක set up කරගන්න ඕනේ. right මේ covered එකේ ගත්තොත් මෙන්න මේක තමයි තියෙන්නේ. The board connected to the strips with the meter bridge wire. Right meter bridge. Okay, and finally connecting wires. Right, finally connecting wires. But how many electricity experiment එකකදී connecting wires තියනවද? ඒක මේජර් එකේ හැම එකකින් connecting wires තියනවා. එහෙම කියලා ඒක මොකද කියන්නේ ඒක විතරයි. හැම එකකින් connecting wires තියනවා. ඒ wires වල ඔය මොනවද කරන්නේ? Right, then apparatus කියලා මේක ගන්නවා. Then apparatus and take down the apparatus. The equations here are not only the apparatus. Take down the apparatus. No need to write the equations yet. Take down the apparatus. Why are we dividing by r dash? The subject independent variable below 100 minus L. Why are accumulators used? Accumulators means accumulator scale, and that's of the single battery. That is a parallel combination of batteries. Accumulator to get a constant current over a long period of time. Right? We'll see those things in the next part. Take down the right form. Right. When we mention the theory, I want to mention about the Dixon bridge again, right? If you don't know about the Dixon bridge, right? You can take this down, right? Otherwise, I'm not going to mention about the Dixon bridge separately under theory, right? Theory, instrument theory, again. Dixon bridge, Dixon bridge. Right? Right. Label this as, label this as, label this as copper wire, copper wire, copper wire, copper wire. Here, spiral. This one, thermometer, thermometer. Right? This one, Bunsen burner, Bunsen burner, Bunsen burner. This one, tripod, tripod. Right? And this one, non-resistor, 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 non-resistor. Right. Then theory, theory, theory. Okay, first write down resistance of a conductor. Resistance of a conductor at 0 degrees Celsius. 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 Resistance of a conductor at 0 degrees Celsius is given by, is given by, is given by. Put a comma and take down the equation. This one. Put a comma and take down the equation. R0 equals R0 1 plus alpha theta. Right? Introduce terms R theta. R theta. Resistance at 0 degrees Celsius. R theta. R theta. Resistance at 0 degrees Celsius. Resistance at 0 degrees Celsius. Right? R0. Resistance at 0 degrees Celsius. R0. Resistance at 0 degrees Celsius. Resistance at 0 degrees Celsius. Alpha. Temperature coefficient of resistivity. Temperature coefficient of resistivity. Temperature coefficient of resistivity. That is also called temperature coefficient of resistance, right? Alpha, temperature coefficient of resistivity. Resistivity equals resistance equals our plan. In signal time also that's same like that. Uष्णते प्रतिरोधकता संग्रह में प्रतिरोधकतावे संग्रह दिलाता ज्ञान पड़ो. Right, then theta present temperature. Theta present temperature. Present temperature. Right, make a difference. I mean, that's a important thing. Make a difference. I mean, otherwise, now as thermal expansion equations, right? Even though it has the same shape, but here we have something at 0 degrees Celsius. Right, the initial one. right? Initial value is 0. And that's why here is exactly the present temperature. Unbelievable. Present temperature. Right? Okay, then try down below. If balance length, if balance length, if balance length, if balance length of meter bridge, if balance length of meter bridge is simple L, if balance length of meter bridge is simple L, if balance length of meter bridge is simple L, put a comma. Then here mention this as at balance point. At balance point. At balance point, mention this R0 over L, R0 L equals R dash over unbalance. And subject R beta, and subject R beta, subject R beta, subject R beta, subject R beta. Right? Then right on. Using equation above, using equation above, using equation above. Combine this column. For R theta in this equation, plug from here. Right? Then also here. Start from here and prove it up to this point. Right, prove it up to this point. Y equals mx plus c. Right, then plot the graph, plot the graph, plot the graph and mention this also. Right? From that, the theory part is over. Right? Graph and make sure you have labeled axis. This axis is unitless, right? That's why unit is mentioned. Length over length, that is the ratio, that is unitless, right? This is 50 Celsius. Finished? Right. Doesn't know? Now before explaining method, right? Method now explain another. Right? Listen. Now basic idea about Metre Bridge and using the Metre Bridge should be known, right? Then never anything. Right now, before starting any experiment, using Metre Bridge or potentiometer, right? They got a common level. A common level, right? Before starting any experiment using Metre Bridge or potentiometer, right? You have to keep the criteria A and B respectively and check whether 70 nanometer deflects from one side to the other, passing 0, right? Opposite sides are unknown, right? If there is deflecting to opposite directions, right, which means you have a balance point in between, right? If there is not deflecting, passing 0, right? Passing 0, which means you are not going to get a balance point, and there are reasons not to obtain balance point in such cases, right? We'll see what they are in the next part, right? First part we are doing is keeping the side here A and B respectively, right? Positive area and negative area at A and B respectively, and I have to check whether 0 nanometer deflect from one side to the other, passing 0, right? Then initially, listen, initially, we close only switch S1. Listen, initially, we close only switch S1, right? Keeping S2 open. When S2 is open, when current passes through the galvanometer, it passes through this resistor. When the switch is open, right? This is a safeguard resistor. Safeguard resistor is to safeguard our galvanometer, because galvanometer is very sensitive. Right? Meters are very galvanometer, they are very sensitive. Right? So therefore, initially S2 is open, only S1 is closed. Right? And then by keeping this open, first you are going to find the rough balance point. Right? Again, over there, rough balance point have power. That is called a rough balance point. Right? Once the rough balance point is known, you know around which length that you are going to obtain balance point. Right? Like a water, gila, side Jaeger, or look current and passes and it both galvanometer. Right? It burns out. Galvanometer gear pass I have another way with the coil level. I don't. Right? I have a galvanometer. Right? I don't know. Right? It has a small Coca-Cola inside. Right? Feature itu boleh kita lihat ini kan feature dalam video kan tiga mana sahaja ya lagi right then first you are getting an idea about the rough balance point and then we are closing S2 also when S2 is closed this resistor is going to short side right then current passes through this and next outside and then you are going to find that exact balance point right rough balance point already is out of plan because close to the balance point, only a small current close to close to the balance point. That's like what the gain of the experiment one and one. Because the real one, there one galvanometer. Right. The area of the idea. And then you have to find that balance point. And at the balance point, have to take the reading of balance length. Right? Balance length. And from the thermometer, have the temperature reading. Say you are starting at 25, right? 25 will start thermometer. Minimum reading at 60 readings. So then right, this has to be recorded. First temperature 1, 2, 3, 4, 5, 6. Right? Say you are starting at 25, 25, 30, 35, you know, very unloaded. 40, 45, 50. Right? And for each temperature, right, balance length is going to differ. Right? Then you will get 6 different balance lengths. Maybe right, this is in centimeters. If L is known, then you can find L over 100 minus L. Right? So next one right? This is a group work. It's a group work. Start correcting note. Right? Because mega read correcting note. Temperature control correcting note. Right? Because balance point check in note. Right? Minimum. Group work right? Right, so likewise, listen to that. Likewise, you have to find the balance point, right? And repeat the same for 6 different readings by changing the temperature by changing the temperature by Pascal, right? When we take the reading at a given temperature, right? We have to make sure that the system remains at that given temperature until you finish taking the reading, right? For that, the flame should be controlled. Flame make family or right? To control the flame, you are taking the Bunsen burner out of the driver and again putting it in, right? Take a cup and the thermal, right? And the other thing is you can increase the temperature of the system like 1 degree Celsius or 2 degrees Celsius above the value required. 25 ना करने हैं अब मेरे 27 वगैरह का heat करना. It was a color Bunsen burner का आई करना and let it cool down and go to the reading at 25. So देखो करंट को बोलो तो देखो यार reading तो right? Well, they have one thermal view. Connections are only. They have thermal view. Okay, then go to mirror. 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 Okay, right now, first point. First point. Connect the circuit. Connect the circuit properly. Connect the circuit properly. Connect the circuit properly. As discussed under apparatus. As discussed under apparatus. Connect the circuit properly. As discussed under apparatus. Right. Next point. Next point. Cross switch S1. Cross switch S1. Cross switch S1. And keep S2 open. And keep S2 open. Keep S2 open. Next point. Next point. Keep slider key. Keep slider key. Keep slider key at A and B respectively. At A and B respectively. At A and B respectively. Keep slider key at A and B respectively. And check the reflection of center zero galvanometer. And check the reflection of center zero galvanometer. And check the reflection of center zero galvanometer. Whether it passes through zero, whether it passes through zero from one side to the other, whether it passes through zero from one side to the other, whether it passes through zero from one side to the other, whether it passes through zero from one side to the other. Next point. Record initial temperature. Record initial temperature. Record initial temperature. Record initial temperature. And find the rough balance point. And find the rough balance point. And find the rough balance point. Rough balance point. Next point. Now close switch S2. Now close switch S2. Now close switch S2. To short circuit. To short circuit. To short circuit. To short circuit. Safeguard resistor. To short circuit. Safeguard resistor. Short circuit. Safeguard resistor. And find the accurate balance point. And find the accurate balance point. And find the accurate balance point. Record. Temperature and balance length. Record temperature and balance length. Record temperature and balance length. At this instance. Repeat the same for at least 6 different readings. Repeat the same for at least 6 different readings. 6 different readings. And record respective theta and L. And record respective theta and L. And record respective theta and L. Record respective theta and L in following table. Record respective theta and L in following table. Take down this table. theta and L in following table. Write down this table. Right? Right. Next point. Next point. Plot the graph between. Plot the graph between. Plot the graph between. Plot the graph between L over 100 minus L and L over 100 minus L. Plot the graph between L over 100 minus L and theta. And theta. Next, beta y. Beta y. Next, beta y. Next point. Beta y. Alpha. Beta y alpha. Using gradient and intercept. Using gradient and intercept as discussed under the beta y alpha. Using gradient and intercept as discussed under the right. That's it. Right. That's it. And again here also, right, there are right, important points, remarks that you need to know about this, right? Maybe the material. Now, you know what the materials are, riders, right? And you know the theory used behind this, the logics, right? And finally, now the method is done, which means experiment is all done. But we have discussed the other remarks here at last, right? Then finally, remarks. 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 The point. No balance point is obtained. Under remarks. Under remarks. First point. No balance point is obtained. 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 If center zero galvanometer, if center zero galvanometer, if center zero galvanometer does not deflect, does not deflect, does not deflect from one side to other. When slider is kept at A and B, when slider is kept at A and B, right? The reasons to happen so is right. Mention reasons. Mention reasons. First one, loose connections, right? Loose connections. Again, may have that. Maybe wires are connected. The loose connection and how. Then are loose connections. those connections. Right. Listen. Right. So first thing, now we have a case for Metre Bridge right? Metre Bridge resistance only came issue Metre Bridge resistance only issue when it comes to potentiometer also we are doing the same practice. A to B and A and B check करना check करना से हम एक नाम secondary circuit है ये तो secondary circuit के issue करना पूरा. But here you don't have a secondary circuit. Yeah, it's only right. So probable reason is a loose connection. Loose connections the end fine. Then the other thing is about this about using safeguard resistor with this plug key, right? And what's the reason to use plug keys now? Yeah, plug keys now. Now we need to have continuous current, right? Maybe temperature current, right? And to make sure the current is steady and current is constant, we are using an accumulator. We are cell use right? That's why accumulator is used. Usually, accumulator in laboratories, a motorcycle battery. Motorcycle battery is take a cells right? That's cells means cells motorcycle battery व्यवस्था मोटरसाइकिल बैटरी का बैल में दान क्या ऐसे लोग आना में हाँ बैटरी का कोई भाई एक एक का मिनी बैटरी का करो अरे हाँ बैटरी को बैल में दान तो हाँ रिसर्च करना मैंने एक का मिनी वर्जन नहीं पाई मैं एक ये cells था they are parallel cells right so we know when we connect cells in parallel combination always EMF remains unchanged EMF remains unchanged के लिए average नहीं मतलब equivalence हम equivalence क्या but E can have level, then equivalent to E here. Right? Only advantage you get is right. You can have a constant current, a steady current for a long period of time. Take a long accumulator use that. Accumulator can battery hour. And then you got a dry cell layer. Right? Accumulator again, dry cell layer. Take a accumulator use currently. Take accumulators, you know, accumulators are not using chemistry one and another pro accumulators. Electrochemistry around thing is enough for that pro. Take a use current motorcycle right? They have none. I don't know. Take use current motorcycle body motorcycle battery. Right? Body can 12 volts. Okay. Then next point right now. Next point right now. Plug keys are used. 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 Since we need a continuous current flow. 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 Since we need a continuous current flow throughout the experiment. Since we need a continuous current flow throughout the experiment. Next point, an accumulator is used. An accumulator is used. An accumulator is used. An accumulator is used to provide a steady current flow throughout a steady current flow throughout the period. To provide a steady current flow throughout the period. Right. So the next thing. When you wrap this around this wooden piece, right? When you wrap this around the wooden piece, you have to make sure that they are not in contact. Because if they are in contact, the wire is going to short circuit, right? The wire again, that mega equivalent that is short circuit, right? And if that wire is an insulated wire, right? If that wire is an insulated wire, that is better, right? Not to short circuit, but when the wire is insulated, even though our temperature of the liquid here is right at say 25, right? It takes much longer to reach to 25 by the wire. The wire එක වටේ insulator එක තිබ්බොත් හරි එහෙම ප්‍රශ්නයක් තියෙනවා. ඔය insulator එකක් තියෙන හොඳයි. there are like pros and cons. Insulator එක තියෙද්දි short connections එන්නේ මේකේ short circuits එන්නේ right? Insulator එක නැත්තම් රත් කරන්න ලේසියි. Right, next point. Wire turns should not be in contact with each other. Wire turns should not be in contact with each other. Wire turns should not be in contact with each other. Else, it should be covered with an insulated cover. Else it should be covered with an insulated cover. To avoid short circuits. Right. And this one very important. As a liquid we use here, right? As a liquid, right? Most commonly what we use here is coconut oil. Right? As a liquid here, what we most commonly use is coconut oil. Right? Level this as coconut oil. Coconut oil. Right? Why coconut oil? Okay, questions are the why we are using coconut oil or glycerin පුළුවන් right common එක තමයි coconut oil sir glycerin වල තියෙන අමාරුයි coconut oil තියෙනවනේ easily ගන්න පුළුවන් right so most commonly coconut oil is used over water question එක අහන්නේ එමය why coconut oil is used without using water what are the reasons what are the possible reasons there are also possibility of conducting current through water, right? Bubble current में देना है ये वाला right? ना rescue होएगी मालूम ये सब तीन जरा एक ही कारण वाले लोड़ा one thing is that तो ये कारण front plane में दी में एक ही power cut करना नहीं एक कितना cut करना power cut करना मतलब मिसो गामा प्लेट नहीं तुम कारण में लगा आई अब यार नहीं गामा प्लेट बाहर क्या serious है कारण में लगा ना अरे एक कितना disconnect करना නැත්තම් අරගෙන පුළුවන් ඉතින් වයර් කියන්නේ උඩින් කියලා ගන්න හැමෝම. හරි? එතෙන්ට පිළිලා නැතත් වයර් එක්සර් කරනවා. අදිශ්‍යයෙන් මම කරේ ලීකේජ් එකක් ගාවොත් නැත්තම් අර ෆ්ලඩ් එකත් එක්ක එනවා දින. යාල් වලින් එහෙම ඔක්කොම ෆ්ලඩ් වෙනවනේ. ඒතකොට නිකන් මේ ප්ලග් පොයින්ට් එකකින් උනත් කරන්ට් එක ලීකේජ් කරන්ට් එකක් එන්න පුළුවන්. ඒ නිසා මුළු ඒරියා එකම ඩිස්කනෙක්ට් කරනවා. Right? So one thing to use coconut oil is water conducts current whereas coconut oil does not conduct current. Right? ඒක මෙතනින් මෙහෙම කරන්ට් පාස් වෙන විදියක් යනවා. නැත්නම් මේ කොයිල් එකේ මෙහෙම කරන්ට් පාස් වුණොත් මේ වැඩේ හරියන්නේ නැහැ. මේක දැන් මෙහෙම කොතනද මෙහෙම කරන්ට් එක ස්පාර්ක් වුණොත් right so the current spark it should spark through the surrounding medium right that's why surrounding medium is being coconut oil okay guys and the next option is if you are taking these readings for a higher range right for a higher range right there's another chance from coconut oil because boiling point of coconut oil is higher than that of water. Right? Boiling point of coconut oil is around 160, 170, usually 170 again. Around 170. Coconut oil is boiling point එක වැඩි. ඒ නිසා අපේ readings මේ වගේ නෙවෙයි. තව ගොඩක් වුණා ඉස්සරහට ගන්නත් පුළුවන්. Right? 120 ඉහළට ගන්න පුළුවන්. Otherwise if you use water, right? Definitely you have to stop before 100. Right? 120 තියා ඊට පස්සේ boiling point එක reach කරනවා. ඒක කරන්න වෙන්නේ නැහැ. නිසා coconut oil වලින් use කරනවා. તો metering also there is same metering වල 160 170 range එකේ තමයි boiling point එක. And the data features say Coconut oil use කරන්නේ ඒක හැම කෙනෙක්ම තියෙන හින්දා. දැන් ගාලේදී ආගල්ලේසි right ඉතින් left එක තියෙනවා. අතයි coconut oil තියෙනවා. Right. Then right on the soil. Soil. Coconut oil is used. Coconut oil is used. Coconut oil is used. Coconut oil is used. Without using water in the vehicle. Without using water in the vehicle. Without using water in the vehicle. Right. Mention reasons. Reasons के अलग mention reasons. First one. Reasons. First one. Coconut oil is a weak. Coconut oil is a weak. Current conductor. Coconut oil is a weak current conductor. Weak again, it's almost no, right? It's a weak current conductor. So there won't be any short circuits. 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 Right? Next point. Next point. Readings can be taken even up to a higher range. Readings can be taken even up to a higher range. Readings can be taken even up to a higher range. Readings can be taken even up to a higher range. Even up to a higher range. Since boiling point of coconut oil is. Since boiling point of coconut oil is. Boiling point of coconut oil is around 170 degrees Celsius. Around 170 degrees Celsius. Around 170 degrees Celsius. Right? Okay. We know there's a heating effect of current, right? Why we don't use current itself to heat this without using this setup? Okay, question because current itself has a heating effect. Right? Current has the order of right? Then when current flows, this overwire itself heated. Right? Then without using these Bunsen burners, these things, right? What if we use that current which flows through the conductor itself to heat this? Temperature right? These are possible questions that can be asked, right? Reason is this. Now, when you increase the current, to increase this, right? All the temperatures here, all the conducting wires, all these copper strips, everything is heated. There's a system of heater. The memory system of heater. Metre Bridge wire resistance. Metre Bridge wire conductor. Copper strips conductors. Conductors. So, right? So, they have a system of resistance. That's going to be a mess. Right? These are current again, that's the main reason. That's the main reason. If you are to do this by using current somehow, okay, external current main current external current but again the thing is it can be controlled. The make a flame control, right? The current can be controlled as this remains at a constant temperature, right? And to heat it to this kind of temperature, right, we need a massive bar, right? And normal milliamperes वगैरह current का flow ना लिया, आता भी चला रहता है ना मेरे, right? मैं क्या करूँ? मैं 30 contact कर temperature there में temperature 30, right? 35 के या फिर ना हम दे रहे हैं, लोग दे रहे हैं, 40 के दे रहे हैं, right? हमारा अब तक ना है क्या? चलो लोगों की डिस्प्लेसमेंट ना कितना पूरा milliampere का, right? हमें डिस्प्लेसमेंट ना करना, लोगों करंट का flow करना है, right? That is impossible, right? हमें करंट आएगा ने यहाँ kiloamperes वगैरह करंट का flow करना है ना, amount, right? higher ampere value का करीब और kiloampere value, जैसा एक चला हरियाणा ना उधर में लोगों करंट का क्या अंदर no current can be around here. Reasons to know. Main reason is that Everything is going to be here if you flow a current through the main circuit. Current flows here, they are putting heat. Okay, next write out. But there are questions there are next write out. Current flows through copper wire can be used. Current flows through copper wire can be used. Current flows through copper wire. Current flows through copper wire. Current flows through copper wire cannot be used to heat the wire. Cannot be used to heat the wire. Mention reasons. Mention reasons. First reason. First reason. All conductor parts. All conductor parts in the circuit. 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 Get heated. Get heated. Get heated. And their resistance. And their resistance. And their resistance varies. And their resistance varies. Right? Next reason. Next reason. Current cannot be controlled. Current cannot be controlled. Current cannot be controlled. Current cannot be controlled. To keep the wire at a constant temperature. To keep the wire at a constant temperature. Right? Next one. Next one. Comparatively, very high current is required. Comparatively, a 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 very high current is required. A very high current is required to heat the wire. To heat the wire sufficiently. To heat the wire sufficiently. Right. Next point. Next point. Write down. A liquid is used to. A liquid is used to. A liquid. Liquid and a Bunsen burner. A liquid and a Bunsen burner is used to. A liquid and a Bunsen burner is used to. A liquid and a Bunsen burner is used to. Make sure the entire wire part. Make sure the entire wire part is heated to the same temperature. 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 And to keep the system. At a required temperature. To keep the system at a required temperature. To keep the system at a required temperature. For a small time interval. For a small time interval. For a small time interval. Until a reading is taken. Until a reading is taken. Until a reading is taken. Right? Next one. Next one. Following methods can be followed. 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 Can be followed. To keep the temperature of system constant. To keep the temperature of system constant. to keep the temperature of system constant until to keep the temperature of system constant until the reading is taken. Right. First one. Controlling flame. Controlling flame of Bunsen burner. Controlling flame of Bunsen burner. Controlling flame of Bunsen burner. Right. Second one. Increasing temperature to a higher temperature. Increasing temperature to a higher temperature. And let the system cool down. And let the system cools down. And let the system cools down. And take a reading. And let the system cools down and take a reading. And let the system cools down and take a reading. However, the thermal Q correct controlling flame and increasing temperature 27 25 reading right. අපි මේ ෆ්ලේම් එක 25 වලදී හරියට වයින් කරොත් එළිය ආවිවෙද්දී මේ ආපු තව තිබ්බ හීට් පාටිකල්ස් තියෙනවනේ ඒ හින්දා මේක ටෙම්පරේචර් එක වැඩි වෙනවා right so either if you take the reading right the system might not be at 25 maybe 25.5 25.8 නැත්නම් 26 වගේ වෙලා වෙන්න පුළුවන් right to eliminate that error these two are below right okay so that's it about this one. And this is again a very popular experiment. Right? You can mistake a question set करवाना, बैटरी लगाना क्या लेते हैं experiments set take नहीं right? A very popular experiment. And also the structure is this, right? मतलब देखने अंदर प्यार है. Okay, any questions? Any doubts? Any questions or doubts about this? Regulators use serial current design tries to just exactly. Wala pa may naam pero bandas ka. Username. Okay, right. Any questions? Am I too fast? When I read out points? No. I'm here. Points can. And then can you reduce the speed? Yeah, man. I was slow to read. Right, now whether we are speed. Okay. Mama, idea करने किसी का आई क्या कर रहा है? उनकी idea रहा है वो क्या रहा है? Okay. Yes. Is it clear now? Clear. Yeah, Leesa. Comparison of cells to comparison of EMFs. Is it clear now? Horana? Okay, then we'll go on. Experiment 3. Experiment 3. Experiment 3. Make it on. निकम बाहर दे रहे हैं और भी and the data shown in figure A cause recording initial temperature so whatever and then ये उड़ गया ज़्यादा देख ले टाइम अभी कम क्वेश्चन था ना आई पकड़ तो ही हो गया ना भाई टाइम है Of balance point, next close switch A1 open accurate balance point, measure and record length, then we the board wires, right. When you I discuss the areas mentioned in the first, we're going to avoid this obtain standard value of alpha from data book and height. Note, when I want maybe I import this one. When preparing the coil of wire, take a cylindrical piece of wood about 10 centimeters in length and diameter about 2.5 centimeters and insulated copper wire 40 WGSW of about 5 meters in length. Bend the wire into a double thread and wrap it around piece of wood as shown in figure. Why we are using a double thread? But they want figure. Why a double thread is preferred? Double thread the insulated wire and threads double thread color. What's the reason? What can be a reason? What can be a reason? When we have a higher length for the wire, we have a higher resistance. Higher resistance, the values you are going to get, right? The values you are going to get here are significant considerable values, right? That's our body values in the length world. Percentage is right? Right. Make it 5 meters वगैरह आएगा करने के 5 meters वगैरह आएगा कि थोड़ा टैप कराने वाले मिनट में आगे लेते हैं right थोड़ा डबल कर लो टैप करने के लिए नहीं always when you use multiple colors right always you can have a higher length ना higher length का तीन होता है yes higher length का तीन होता है because then you can get considerable resistance values considerable है क्या के लिए यहाँ comparatively होता है क्या otherwise, if this value is too small compared to this, right? This is a common defect we have in a Metre Bridge, right? If this value is too small compared to this, right? Your balance point is going to bias somewhere here. Body balance length that right? When you get a smaller balance length, percentage errors of that readings are very high, right? That's why it is advised to use a lengthier wire guard, right? Take a lengthier that's why this double string is different. Right? Double string. Okay. Right. Let's move on. Go to experiment 3. Here. Right. Go to experiment 3. Right. Write down comparison of EMFs of electromotive forces of comparison of EMFs of two cells using potentiometer. Comparison of electromotive forces of two cells using potentiometer. Right. Experiment 3. Listen. Again, I'm going to start the explanation with the apparatus, right? Then we'll come to the materials, right? Apparatus now with the right. Now, as I told you in the Metre Bridge, right? You should be able to draw and label all parts of a potentiometer as well, right? Why are we using potentiometers? Just ask me. What's the benefit or what's the purpose of using a potentiometer over a voltmeter? What is measured by potentiometer? Potential difference, right? To measure potential difference, we have voltmeters as well, and there is a handy instrument, right? When it comes to potentiometer, that is kind of a large setup, right? Table setup. The eye is around 1 meter long, right? 1 meter, 2 meter, 4, 8, potentiometers there, right? 8 kilometers in one line 8 now, is still, right? So, what's the benefit of using potentiometer over the voltmeter? Voltmeter. No. Then when what reason? If voltmeter has a finite resistance, it absorbs a potential difference. It absorbs the current. When it absorbs the current, it absorbs the potential difference, right? And even when you are trying to read a potential difference, take a potential difference using a voltmeter. Voltmeter itself absorbs some potential from the source, right? So therefore, you are never going to read the exact potential difference in between the 2 points you wish to find the potential difference, right? To eliminate that error, we have potentiometer. To eliminate that error, using potentiometer, when that is balanced, right, that is not going to absorb any kind of potential from the circuit. Circuit can absorb current. Right? That's the main benefit over voltmeter. Right? Pros and cons are making clear. Voltmeter is mobile, right? It's mobile and it's convenient to use, but the accuracy is low. Right? Thermometers වගේ තමයි. Thermometers ගොඩක් තිබ්බට එක එක දේවල් වලට. ඒ වගේ තමයි. Right? දෙකෙන් එකම දේ කරන්නේ. ඒකේ තාරාවේ කණිකම් එකයි. හරි. ඒ වගේ. හරි. Potentiometer එක efficiency ගන්නත් ඒකයි. ඉතින් යාර එච්චර accuracy එකක් ඕනේ නැහැ. Potentiometers are used to find something with a higher accuracy. Right? Find potential difference with a higher accuracy. දැන් electric වැඩ කරන කෙනෙක් කියන්නේ electric වැඩ කරනවා මේ wiring වැඩ කරන කෙනෙක්. Right? Checking whether it's 220 or 230, that is enough. Take a 229.9 ද කියන එක doesn't matter. sensitivity එකක් ඕනේ නැහැ. Right? That's the thing. Everything මේ වගේ කට්ටිය potentiometers අරගෙන වැඩ කරන්නේ නැහැ. They have voltmeters or rather multimeters. Right? Potentiometer එකේ තියෙන්නේ if our focus is accuracy. If our main focus is accuracy, the only option we got is potentiometer. accuracy replace කරන්න බෑ voltmeter එක. Right? ඒකයි potentiometer වගේ instrument එක අපි use කරන්නේ. Right? Keep that in mind. Okay. So when it comes to potentiometer, right? Start the potentiometer from potentiometer wire. Right? here are the start the potentiometer from potentiometer wire. Potentiometer wire is also labeled as A and B. Standard labels they are A and B. Right? And it has an accumulator. Right? And a plug key. Right? And if we need a variable resistor, we can fix a variable resistor here also, right? Depends. That depends. Take compulsory. Whether or not you set a pull. If I need a variable resistor, right? Take a compulsory, right? Variable resistor, because the reason to connect a variable resistor is when the variable resistor is connected, the rheostat is connected, you can easily change the potential difference between potentiometer wire by changing the resistance here. Right? When this changes, K of potentiometer changes. What is K? Potential drop by radial changes. Right? Now for this purpose, right? This is modified like this. Right? These two are the two batteries that we are going to compare EMFs of, right? Say E1 and E2. Right? Even though there are internal resistance, that doesn't matter because when we balance this to a battery, there won't be any current flow through the battery. Right? You will see in the next part. Then internal resistance is negative. Right? And here, this is a two-way switch. Right? This is a two-way switch. Right? That's a two-way switch. Right? And this part is same as that of the meter bridge. Right? Same as the galvanometer with the side key. Right? Now, say the accumulator is S1. This is S2. Both are plug keys. And variable resistor here is say R dash, E1, E2. Right. And this is the safeguard resistor and the zero galvanometer. Right. Okay. Now, what we do is this. Listen. What is the principle of a potentiometer? Right? Now, as the principle of a meter which is itself, right? What is the principle of a potentiometer? Principle of a potentiometer. It works from Ohm's laws. EAC equals K, right? EAC equals K. Potential difference is written as potential difference from A to C. C is the balance point, right? Is written as right. Now we are calculating a value called potential drop per unit length of potentiometer. Potential drop per unit length, right? Potentiometer Y is potentiometer Y, right? So when current flows in the main circuit, this is a conductor wire. If there is a conductor wire, it has a finite resistance. Right? When current flows, then it has a potential difference. Right? That means potential drop per unit length. Potential drop per unit length that is given by total potential difference across the wire over total length of the wire. Right? Total potential difference across the wire over total length of the wire. As an example, say total potential difference across the potentiometer Y is 10 volts and length of potentiometer Y is 100 meters. 100 centimeters, 1 meter. Right? Then potential drop is 0.1 volts. Right? 0.1 per centimeter. That value is called potential drop per unit length. Right? If there is known, when we find the balance point, right? Only explain before jumping into the experiment, right? This is some background about, right? Just a background about potentiometer. Before starting anything, as we did in Metre Bridge, you have to keep the side A and B respectively and check whether galvanometer deflects from one side to the other, right? If it deflects only, you are going to get a balance point in between, right? Then find the balance point. After finding balance point, what happens is this. At the balance point, balance means no current flows to galvanometer. Right? If no current flows to galvanometer, right? This is inactive. Since there is inactive, up to here there is the same point. Right? No current flows, no potential drop. Then same potential remains. Up until here. This is also C. Right? And since this is A, this side is anyway A, this is also A. Right? Now at the balance point, potential drop of this part of the wire is VAC. Potential drop of the wire is VAC. Now using this, we can write it as K times LAC. Because if potential drop per unit length of Metre Bridge wire is potentiometer wire is known, right? Potentiometer wire is known. Then if this length is known, say you need the potential difference for a length of 45 centimeters, then and this VAC across the potentiometer wire is exactly same as potential difference across the device connected here. The device connected here, AC. Right? Then in this case, then this equals to E1. Right? Principal length. This is the principal. Right? This is the principal. Potential drop and potential drop scale. Potential drop scale. Potential drop scale. Using Ohm's law, IR will drop back, right? Go to V equals IR, The principle is Ohm's law. DAC equals K, right? You can write potential drop back in here of potentiometer wire using K, right? Now, if this is balanced to the secondary circuit, this is called the below loop secondary circuit, right? Sub loop, right? In the secondary circuit, this is AC. Right, PAC, and exactly the battery E1 is connected. In this case, right, now in this case, E1 equals K LAC, right? So likewise, you can measure potential difference of that device connected in the secondary circuit using the potentiometer wire. Right? Right? And there are similarities, right? There are around like 50%, 60% similarities with Metre Bridge. Practices same or right? As an instrument that is different, but when we are dealing with sliders and wires, the common practices theme, they of course same. Right? Okay. Now, say what we do is this. Keeping side at A and B and checking the our sensitive parameter deflects from one side to the other and make sure whether there's a balance point, right? If there's balance point, then by keeping the side B on the potentiometer wire, we are finding a balance point, right? Finding a balance point. And here also, until you find the unbalanced point, switch S2 is over, right? Until you find the unbalanced point, S2 is over. right? Because we have to safeguard this, we have to protect this, right? And then once a balance point is found, then causing S2 to short circuit this let the current flows through this and find in that accurate exact balance point, right? M balance point above. Then at the balance point, say my circuit is connected to here, circuit can 2S will check, 2S will learn, right? Say 2S is connected to here, then it is going to measure the potential difference across cell E1 at the balance point, right? Can I logic here? At balance point, at balance point, as balance at balance point, what's the current flows through galvanometer? What's the current flows through galvanometer? 0. If no current flows through galvanometer, there's no current flows through battery as well, and no current flows through this part as well, right? That means this is the current, right? What about the main loop? Current in the main loop. There's an zero current in the main loop. Main loop is current, right? Primary circuit secondary circuit. Right. Now in this case, let's say balance length obtained for cell E1 is L1, right? Then at this point, you know, VAC equals VAC, maybe VAC equals VAC. And one side can be written using potentiometer wire L1, if balance length is L1, right? And the other side using the secondary circuit E1, right? Repeating the same by connecting this two edges to here, right? Once this is connected to here, this becomes an open circuit, and this point is going to connect here, right? Then this is going to connect with this point. Make a balance not. Then, if that balance length is L2 for the E2 for cell E2, then again at the balance point VAC equals VAC using potentiometer L2 balance to E2. Right? Comparison means just the ratio, finding the ratio. Comparison finding the ratio. Then here K remains unchanged because we didn't change the one table dependence or no. We didn't change total potential difference of LAB. Why change change? Potential difference change if you change either accumulator or this rheostat. Right? Make a change K depends only on EAB and LAB. I mean, since K is same, that is same, and L1 and L2 are measurable lengths, right? They are known lengths. Since L1 and L2 are known, right? Here create one node, right? E1 node, E2. That is L1 node, L2. This is called comparison of PM. Right? That's it. The only thing you can say after comparison is, right? The multiple here, right? 2E1 equals 3E2. And then compare them. Right? Comparison right? Okay, then first mention materials. Right, right, mention a potentiometer. A potentiometer. Right, then a rheostat. Within brackets optional. An accumulator. Then two plug keys. Then send a zero galvanometer. Safeguard resistor. Within brackets about 5 ohms. About 5 ohms. Safeguard resistor. About 5 ohms. Then a two-way switch. a two-way switch. Two dry cells. Two dry cells. Two dry cells. Two dry cells. Then slide again. Slide again. And finally, what? Connecting wires. Connecting wires. What are you connecting wires from here? Right, okay. Then apparatus. 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 Take it down. Apparatus later. Take down the apparatus. Make sure all parts are properly connected. Right? Connections are in electricity always you have to know the connections. Connections is know this time. Negative switch negative switch understand that. You just need to know the connection. Connection is right? Circuit always understand the connection. This is connected to this. This is connected to this. Right? More right? The papers are right? These things are given just as the physical appearance. Physical instrument, physical device, they have to circuit physical right? Last always, that's why you have to know the connection. Connections, however. Okay, next. Alright, so then theory. 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 Right now, if potential drop per theory, if potential drop per unit length of if potential drop per unit length of if potential drop per unit length of potentiometer wire is K. If potential drop per unit length of potentiometer wire is K, put a comma and text down K equals VAB over LAB. A equals PAV over LAV. Right? Next point. Next point. If potential drop, potential difference, if potential difference, if potential difference between A and C, between A and C of potentiometer wire, of potentiometer wire is VAC, is VAC, is VAC. Come on, then write this down. VAC equals K times LAC. VAC equals K times LAC. VAC equals K times LAC. VAC equals L times K times LAC. Right? And level is the principle of potentiometer. Right? Hold on, principle of potentiometer. Okay. Then find out. If balance length for cell E1, if balance length for cell E1, if balance length for cell E1, if balance length for cell E1 is L1, right? Within brackets, when two-way switch is connected with E1, when two-way switch is connected with E1, when two-way switch is connected with E1, right? Measure this. At balance point, VAC equals VAC, KL1 equals E1. Right? KL1 equals E1. Maybe right. At balance point, VAC equals VAC, KL1 equals E1. Right? E1 take balance length, balance length L1 L1. And at this is L. Right? This is L. At LAC. Right? And potential drop across this part equals to potential drop here because they are same points, same potentials. Right? Then this is E1 from the secondary circuit, right? And KL1 from the potentiometer wire from the main circuit, right? Next point, if balance length, if balance length, if balance length, if balance length, if balance length for cell E2, for cell E2, for cell E2 is, for cell E2 is L2, for cell E2 is L2. Within brackets, connect two-way switch with E2. 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 Right, again, right now at balance point, at balance point, at balance point, right? Now only this part. VAC equals VAC, KL2 equals E2. VAC equals VAC, KL2 equals E2. Right? There. KL2 equals E2, VAC equals VAC, KL2 equals E2. Right? Then this. Therefore, 1 over 2 is E1 over E2 equals L1 over L2. Right? Then method. 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 Right. First thing is you have to have all proper connections, right? Proper connections. You say A, T, and the other. Right? Find out what's going. Set up the circuit. Set up the circuit. Set up the circuit. As discussed under apparatus. Set up the circuit as discussed under apparatus. Set up the circuit as discussed under apparatus. Right. Second point. close switch S1, close switch S1, and keep S2 open, and keep S2 open. Keep S1, switch S1 close and keep S2 open, and keep the slider key at A and B respectively. Keep the slider key at A and B respectively. At A and B respectively. And check whether galvanometer deflects from one side to other passing 0. And check whether galvanometer deflects from one side to other passing 0. Whether galvanometer deflects from one side to other passing 0. Right? Within brackets, no balance point is obtained. Within brackets, no balance point is obtained. No balance point is obtained. If deflection is only at one side. If deflection is only at one side. If deflection is only at one side, right? Okay. Next. Keep the slider key on potentiometer wire. Keep the slider key and keep the slider key and then on keep the slider key on potentiometer wire. Keep the slider key on potentiometer wire. Keep the slider key on potentiometer wire. On potentiometer wire. And find a rough balance point. And find a rough balance point. And find a rough balance point. Alright, then the wire switch is closed. Right over. Item team loading with structure delay. Right. Then right on. Close S2, close S2, close S2, close S2. And find the accurate balance point. Close S2 and find the accurate balance point. Measure and record. Measure and record. Measure and record. Measure and record. Balance length obtained 4. Measure and record. Balance length obtained 4. Measure and record. Balance length obtained 4. E1 and E2. Measure and record. Balance length obtained 4. E1 and E2. Within brackets L1 and L2. Within brackets L1 and L2. Next. Compare E1 and E2. Compare E1 and E2 as discussed under the array. Compare E1 and E2 as discussed under the array. Compare E1 and E2 as discussed under the array. Right. Experiment here was sitting on background they were doing right about potentiometer. Right? Right. The experiment here there's another experiment coming from potentiometer and these background things, right? Other than that, there are like 80%, 90% of things they are common to any potentiometer, right? They practices, they are and they are common for the next experiment also, right? Remarks. demands. Right, first one. Right, listen. Now, what if we are going to compare? What if you are going to compare even a video without using a potentiometer? Right? And potentiometer use करना है correct? If we try to compare even a video without using a potentiometer, so if you are not using a potentiometer, how to find even? Compare never. Can I even you do never? How to connect a voltmeter across two ends of the cell. Right? Voltmeter connect करूँगा आप लोग लेकिन जहाँ से current flows through voltmeter by the cell. Right? ये रहेगा क्या? Right? एक हमारी अभी एक डेढ़ एम है. නැත්තම් ඉතින් easily මේක voltmeter එකට අරගෙන voltmeter එකට terminals එක තියෙනවා. නිකන් මේ බැටරි එකේ දෙපැත්තට මේක තියක් තියෙනවා. ඒක උගා voltmeter reading එක. Right? හැබැයි ඒක වැරදි because there's a current flows through the cell at that point. Right? And the voltmeter at that point. ये देखिए current එක flow. Current එක flow කරන්නේ නැතුව measure කරන්න කියන්නේ. Right? We should be able to take this reading when there's no current through the battery. Right? Otherwise, our first experiment even when a current goes to the battery, E equals E minus IR. Right? When current is zero only, potential difference equals E. Right? That's the state we use here. Right? And we have to make sure that there's no current flows. A the potentiometer we can use now. Right? First point right now. Potentiometer is used. Potentiometer is used. Potentiometer is used. Potentiometer is used to accurately measure EMF. To accurately measure EMF. To accurately measure EMF without drawing a current through cell. Without drawing a current through cell. Right, listen. Next point. If we didn't get the deflection from one side to the other, right? There can be several reasons. First step one, loose connections, right? Loose connection. Now here there are some other reasons. If E1 of this cell is greater than E node, right? Because from the E node, VAB supplied to the potentiometer wire, right? E node part and VAB. If this potential difference is, if this EMF is greater than E node, right? This potential difference can never be balanced by the total length even of the potentiometer wire. 10 volts here. If you have connected the EMF of 20 here, it is not going to balance the wire. But in that case, your deflection is only at one side. Then in that case, there is only at one side. Right? Or else, right? If this is improperly connected, plus to minus or minus to plus, right? What is it? Positive terminal of potentiometer wire. That positive terminal to positive terminal of this battery should be connected. Positive, negative, positive, negative. Right? If you have switched these two also, right? There can be a single sided deflection. Right? For the reasons. The area check right? Next point, right now. If barometer does not deflect from one side to other. If barometer does not deflect from one side to other. Which can be due to following reasons. Which can be due to following reasons. Major reasons. First one, loose connections. Loose connections. Loose connections. Second one, having a higher EMF. For the cells. for the cells. Having a higher EMF for the cells in second disaggregate. Having a higher EMF for the cells in second disaggregate. Having a higher EMF for the cells in the second disaggregate. Right, next one. Next reason. Next reason. Terminals of cells. Terminals of cells. Terminals of cells. Reasons from here. Third reason, terminals of cells can be switched and connected improperly. Can be switched and connected improperly. Within brackets plus to minus. Within brackets plus to minus. Right, next. I give up. Alright, we don't have to care about internal resistance of these batteries as no current flows through the cell. Right? When no current flows, internal resistance is inactive. Does not matter. There is inactive. Here, right, next point. Internal resistance of cells. Internal resistance of cells. Next is sorry, next point. Next point. Next point. Next point. Internal resistance of cells. Internal resistance of cells. Are not involved. Are not involved. Since they are inactive. Since they are inactive. Since they are inactive. When there's no current. When there's no current through the battery or through the cell. When there's no current through the cell. When there's no current through the cell. Right? And that's the make mention question plan. These are logic I mentioned. Right? That's formula. Right, next. Right, listen. If we need high accuracy, right? If we need high accuracy, this can be developed to a graphical method, right? Corner current below. High accuracy का corner. Then अभी कपारिंग एलोनेट लोड की से current रखा रहता है यहाँ से, right? That's how we do. But if we need high accuracy, okay, standard can work. Horana extensions, right? Whether you can use a graphical method, of course you can use graphical method. Use करना full हो. प्रश्न है, right? If you are using graphical method, right? What we have to do is, then we have to adjust from the we have set here variable resistor here and find minimum 6 different balance points, right? E1 balance points or no E2 to R, right? Graph right? It is doable. It is doable, right? As the next point, just mention this. This can be extended to a graphical method. 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 Right? Taking experimental karan hai. Graphical method tempo all ke liye diya. Taking experimental karan hai, but always there can be questions about that also. Right now, graph का ज़्यादा लेना ना. Graph का नहीं लेना है. Graph लेना है. पूरा लिया मिक्स करके नहीं. Then के लिए नहीं अपने क्या होगा? भाई ऐसे this extended किधर? This can be extended to a graphical method by changing the variable resistor. By changing the variable resistor for minimum of 6 different instances. For minimum of 6 different instances. For minimum of 6 different instances. Right? Like right? Then from this equation from above, right? We know even though E2 equals, right? L1 no L2, right? Now for a given value of k here again we are changing over understanding, right? For a given value of r dash, so for a given value of k, you have to have a pair, then we are going to change L1 and L2, right? Resistance is set kala again 10 ohms are you are getting L1 and L2. For 20 again L1 and L2. They are different values. For 30 ohms L1 and L2 are over there 60 points right? And plot L2 with L1. Then L2 is given by E2 over E1 L1. Now if you plot the graph, right? L2 with L1 make a 6 Coulomb, right? That is y equals mx. And gradient of graph gives comparison, right? E2 over E1 and E1 over E2 on the graph, right? This is also extendable, right? That is extendable. Right. One more thing. Without using a rheostat, it is asked whether we can use a resistor box for the other. Make a resistor box and use can right. Again, resistor box and use can do we need to continuously change this? Do we need to continuously change it from point to point? No. What elevator set so even a resistor box is possible. Right? Here they are explaining. Either resistor box or rheostat, either a resistor box or rheostat, can be used as the variable resistor for this experiment. Right. Now there also, now if you need to make sure, right, if you need to make sure, right, whether the accumulator is discharged, right? So simply, if you need to make sure whether K of this potentiometer is changed. Because if K changes, everything changes. K cancel right? And if you need to check whether K is changed throughout the experiment, right? K depends on AB and LAB, right? What you can do is we can take the initial reading again. Right? You can take the initial reading again at the end of the experiment and check whether it is tallying with the initial reading, right? If there is a drop value from the initial reading, which means accumulator is discharged, considerable. The accumulator higher than anything, you replace higher. Right? Last point. To check whether K of potentiometer, to check whether K of potentiometer has changed during the experiment, has changed during the experiment. Take the initial reading again. And compare it. Take the initial reading again and compare it. Right. That's it. Let's see what is given here. Is closed while Jaeger is kept open. Right, over the switches can on switch take open करना तो switches can on And to a essentially E1 and the by was starting the ideal area now. Okay. Right. Not after setting up the circuit, the E1 is closed and the circuit is tested by connecting the two-way switch to either of the cells E1 or E2 and touching by side switch. Then the wires, then the galvanometer doesn't show when we got one Q up, but this is not the important part. The galvanometer doesn't show deflections in opposite directions. On the two occasions, the circuit is right. The galvanometer deflection is in the same direction on both sides. So remedial reasons instead of connecting the positive terminal of cells to switching terminals, there could be a loose connection, right? Loose connection right? Loose connection at in any circuit, loose connection it's a common one. Potentiometer is discharge and hence electronic force is less than those even given. Also, the calculation of no deflection when the sliding contact the others A and B, the wires test whether the disconnections. Right. Again, listen, if galvanometer shows no deflection at all, when you give slide at A and B, right? Galvanometer shows no deflection at all. Center zero, right? Center zero indicator, center zero, right? You know anything? Disconnection not loose connections, it should be a disconnection. Right? Disconnection and right? Right? Open circuit idea if there's no current flows, it must be an open circuit. Open circuit disconnect. Right? Right? If there's no deflection at all, that's a disconnection. The ratio of electronic forces, right? Negative one. Right, because potentiometer with wires of different lengths are available, right? Starting from 1 meter, 2 meters, 1 meter, right? 1, 2, 4, 8, right? 4 on the end, 4 is the 4 potentiometer. I think you have seen in questions, right? Question to 0, right? This is how that wire is, right? We 400 meters, 400 centimeters, 4 meters. Right, so likewise, periodic wires, potentiometer wires connected to the board. If we need a higher length, what's the benefit when we have higher length? Higher length means lesser K, right? Here are now impact K equals VAB over LAB. Higher length, lesser K. Lesser K means that is highly sensitive, right? Lesser K. Potential drop by unit length is less, right? Which means, especially when you are measuring a small potential difference using potentiometer, right? This is a 90%. Right? Using measuring small potential differences using potentiometer by connecting other resistance is combination with the potentiometer, right? If the length is increased, K decreases. When K decreases, even if you measure a small potential difference using this, a considerably high length is coming as the balance length. But K K product K not? Now be logical, right? K then percentage of readings are high even if you measure, even when you measure small potential difference, right? And make whether bias to have an error study. Because even this has an interaction, even though we are integrated. Corrections from theorem. Correction can integrate made out in the right? So, centimeter half of 1 centimeter correction and integrate. But for a value like 50, 60 centimeters of balance length, right? Neglecting correction of say 1 centimeter, 0.1 centimeters, that is kind of reasonable, right? Right. It says these lengths 2 meters, 8 meters, so on. So essentially to be concerned about the lengths of the potentiometer wires when measured by input. Right. Again, when you measure by the meter ruler, right? Right. Say The slider is here now, and point A is here. Point A is here, B is here. Then potentiometer, right? May I replace them? May I replace them? 1, 2, 3, 4. May I replace them? Then this is 4 meters. Then here 400 meters potentiometer is a 400 meter potentiometer. Right? Say you have got the balance point. Say you have got the balance point here. You got the balance point here. Right? And from the meter scale, from the meter scale, you read this value as, right? You read this value as, let's say, right? You read this value as, say, 40 meters, 40 centimeters, right? Now what's the balance then? I need LAC, but I need LAC. A is here, 100, 200, never 260. Never. Unnever. I can't tell him A to, but I indicate the length from A to C. A to C. Make a 40 the system. Then it comes as 260 centimeters. Right. So likewise, you have to be a little bit conscious and mindful. If that's a case, 100 meters, 100 centimeters, then easily going to blow. Right? Become a meter scale. Bent the product. Yeah, we go. Is it clear? Right? That's 40 kilos. 40 that's the thing. What you are reading is 40. What you are reading is 40. Right? Balance like 40. Okay. Any questions? Any questions? Any questions? Here? Addition? Clear? Right. You know what? Online? Any questions? Right. Okay. Because we are going to take a break. So before we take a break, any questions? Yeah. Right. Then no questions. We'll have a break. Right? We'll have a break. This is the grade 1 and the last one. Again, we're now with grade 1 and the last for the day. Then 30, right? We're another 15 minutes in. Right. ഇപ്പൊ കാലം കേരള ഇപ്പൊ കാലം കാണാം ഇതിപ്പോ വടക്കൻ ഇപ്പൊ Okay. Right. Yes, Right. Right. 61.4. 61.4. Right now, determination of. Determination of. Determination of. Internal resistance of a cell. Determination of internal resistance of a cell. Using potentiometer. Determination of internal resistance of a cell using potentiometer. Determination of internal resistance of a cell using potentiometer. Okay. So let's start our to the circuit until others are coming. So there are some to come. Right. See. In terms of potentiometer, this part remains same in any carbon potentiometer. Right. And the secondary circuit changes. The secondary circuit changes. Right. Now to find internal resistance of the cell, there should be a current flows through the cell. Right. And to have a current flow through the cell, this should be connected as a closed loop because if only the single battery is connected, right? There are only a current for the through the cell, right? But when we get a load, then there can be currents through the cell, right? Right. So when it comes to apparatus, again, always the same as zero. Using the apparatus, oh, using the apparatus, first using the materials, right? Materials. Paper chain has no, right? Running every other problem, materials. Materials, major materials. Potentiometer, a potentiometer, a potentiometer, a potentiometer, an accumulator, right? An accumulator, an accumulator, an accumulator. Two plug keys, two plug keys, two plug keys, two plug keys. Two plug keys and one tap key. Two plug keys and one tap key. Two plug keys, one tap key. One tap key. A dry cell, a dry cell, a dry cell, a dry cell. Center zero galvanometer, a dry cell, then center zero galvanometer, center zero galvanometer, center zero galvanometer. Slide again, slide again. Safeguard resistor, safeguard resistor. Safeguard resistor. Within brackets, about 5 kilowatts. Within brackets, about 5 kilowatts. About 5 kilowatts. Right. That's all. Now, as apparatus, take it out. As apparatus, take it out. Take out the apparatus. Take out the apparatus. In the apparatus. Take out the apparatus. Right, take out. Materials apparatus. materials के डालने की बताया आपने reduction के price से लेगा 2 plus is 130 right और commodity का इतना से okay next right now since I have explained the background about potentiometer in the last experiment right now usually you can do this as an experiment the content in the experiment is a little bit higher but the thing is I explained the background things about potentiometer before right so then without explaining things we can move right other then method sorry here right so here what we do is this listen now our target is finding the resistance of the loop to find the internal resistance first thing is that internal resistance should be activated right that's why only the cell is not connected if only the cell is connected right if only the cell is connected at the balance point no current flows to this part if no current flows right as I explained before that internal resistor is inactive right active in that then you have to make a secondary circuit here secondary loop right sub loop here to flow the current right now what happens is this now this is how the circuit works now even at the balance point let's say balance point is here even at the balance point right even at the balance point since this is a separate loop this is active right this is active the reason again is since we are finding R of this battery right if there is a continuous current flows through this is a digestion right maybe digestion yeah maybe the accumulator will provide the steady current but not the digestion therefore this key is active right they would have label active is active right and the chromatar and they have keys they have keys right they are not clear the reason to use an active here is when this loop is closed there is a current flows through this loop right if there is continuously closed due to the dry cell is going to discharge right discharge the angle of the existing current going on that is the that's one idea also you can keep that in mind okay see now when this is closed right yes it's a closed area when this is closed from this there is a current flows through this sub loop secondary loop like this one right when a current flows internal resistance is active right now there is active but at the balance point still there are no currents to the galvanometer at the balance point balance again right there are no currents to the galvanometer since there are no currents to the galvanometer if this point is C there is no potential difference across any of these devices up to here there will be C right since this point is A this is an area A if there is A this is also A if this is C this is also C right there are galvanometer again At the balance point, since there is no current through the galvanometer, since there is no current through the self resistor, right? No potential difference across this part. Then if this point is C, this is also same as point C, right? Or the other equal. Now, what we are doing is this: finding a balance point again. After properly connecting this, keeping finder at A and B, checking the reflection of galvanometer, whether it passes through 0 to one side to the other, right? Accommodate karna. Then you have to find the balance point, right? But the balance point that is going to balance to AC, right? Make a balance point, right? From the battery, you can write this potential difference either as E minus IR. From the resistor, you can write the same as IR. Because this battery, this resistor, are in a series in a parallel combination now, AC to AC, right? Now, this is what we do at balance point. At balance point. At balance point. At balance point. Again, VAC equals VAC. VAC equals VAC. Now, from the circuit and from the wire, we can expand VAC from the potentiometer wire, that is K. If K of the potentiometer is K, right? Potentiometer is K, KL equals VAC. From the circuit, you can either write the same using the cell or using the resistor, right? I'm going to use the resistor. Using resistor, this is IR, right? Now we need I, right? This is a closed loop. To find the current of a closed loop, what are the measures here? Kirchhoff, right? Obvious when it is Kirchhoff, right? Apply Kirchhoff. Then for this second below loop, apply Kirchhoff laws. Right. Then in this section, sigma E equals sigma IR. Sigma E, only one battery, E. Right? Simple I, current simple I flows through both resistors, simple R, capital R, and simple R plus capital R. Current in the circuit is given by E over simple R plus capital R. Right? Plug this current here. Plug this current here. Then KL equals I is E, then R over R plus R. Right, now check the variables again. Now, with the experiment, from these variables, what are the constants and what are the variables? K and what? Constant variable here. K, constant L, variable simple R, constant capital R, variable, right? Whereas points here, E is a constant. Then capital R is a variable. Capital R is here. Whether in. Now we are going to change this resistor. Right? We are going to change this resistor. Now, instead of this resistor, right? Usually we connect a resistor box here. Right? We connect a resistor box here. Symbol and we connect a resistor box here. Right? Now, R is our independent or dependent. R. How change R change change. When R changes, only L changes. Then R is our independent variable X. Right? R is X. Right? R is X. R X. L is Y. Right? But we need a linear curve. We need a linear variation. To get a linear variation, right? Now R is spread to two sides. Right? Put this one more. After both sides one more PL equals this is R plus R over ER. Now you can divide this two terms separately. This side is still one over KL. If we divide this separately, this becomes R over ER. Right? And this becomes 1 over E. R cancels. Right? ER cancels. Then this cancels. Then subject 1 over L. Then K R over E. Since my variable is R, I'm isolating this part. And K over E. Right? Now, to get a linear variation, right? We must consider 1 over L as 1 over R as independent variable and 1 over L as dependent variable. Right? L R is there, then variables are 1 over R and 1 over L. Variables are but our axes are 1 over L and 1 over R. Right? Now the graph is, right? This is considered as X. right? This gradient intercept dependent, right? Now, if we plot the graph, you plot the graph, right? Shape is y equal to fuzzy, y is 1 over the limits per centimeter, right? And 1 over r, x 1 over per ohm, that is elements fuzzy, right? This is a graph. Intercept is k over e, and the gradient of graph is kr over e, right? Kr over e, right? Now, what is our target? Target. Simple R, internal resistance. What's the easiest way to find simple R after this gradient again? Intercept again. Gradient over intercept, right? Gradient over intercept. We are not going to find K, right? We are not going to find K. K is just used for the sake of writing these equations, right? K one will be right? K one will everything up in one, that's the thing, right? So usually we don't find K for experiment experiments, right? K का use करना, cancel करना, right? Alright. Now, easiest and the best way to find simple R is gradient over intercept. Gradient over intercept is simple R. So likewise, we can find simple R if the graph is plot. Right? Right. What's the idea? Right. और then electricity वाला हम लोग फिजिक्स के पास experiments आता है, right? When they ask for experiments, so you can easily guess what might come, right? Modified bin but if there is not a modified one, it is something out of these four, right? Sometimes structure say four can be modified with magnetic fields here, right? Inversions similar here. But yeah, take a rea, in the very take a rea, negated electricity question may not either in may last stage. Other either in everything, Eva, prepare and Ramana can get in and when it comes to structure, right? They are the ones you are bringing from home. And if they are make them, this is something you know. I take a running Java, so you have to think at that moment that then only you can do it. There is something from something you know before, right? But from 80 marks here, right? You can assure like 65, 70 marks, right? 65 like 65 marks, right? If you know all experiments. Additional thinking say usually for the last two parts, thinking is added on, right? Understanding around 65, 64, 65, all right. What is that? Okay. Then mention theory. Write down. If balance length, write down. If balance length, if balance length, if balance length, if balance length is simple L, if balance length is simple L, right? Start from here. Current account, right? Negative current negative, then plug the value, divide, according to up to this point. I'll find the current also. Why extra variable resistor used in circuit? I mentioned before in the last experiment also. Last video, that is optional. Right? That is optional. Why we are using the variable resistor? To change K is needed. To change K. Right? That is optional. Calling your giver. I don't give it back. Optional. Right? This one is optional. You are there in the last one. Okay, right? Method. 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 That's why. That's why. Connect the circuit. Connect the circuit. Properly. As mentioned under. As mentioned under apparatus. Connect the circuit properly as mentioned under apparatus. Keep strategy as 10 we are calling the other one repeated there. Right, second one. Keep strategy at A and B. Keep strategy at A and B. Keep strategy at A and B. Respectively. Respectively. And check the reflection of galvanometer. And check the reflection of galvanometer. And check the reflection of galvanometer. Whether it passes through 0 from one side to the other. Whether it passes through 0 from one side to the other. Whether it passes through 0 from one side to the other. Passes through 0 from one side to the other. Next point. Cross S2. Cross S2. Cross S2. Cross S2. And find rough balance point. Cross S2 and find the accurate 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 balance point. And find the accurate balance point. Next point. Next point. Repeat the same. Repeat the same. Repeat the same. For minimum of. Repeat the same. Repeat the same. For minimum of 6 different values. 6 different values. For capital R. 6 different values for capital R. By changing the resistance of resistor box. By changing the resistance of resistor box. Label this as resistor box. Label this as resistor box. Right, next. From the variation between. From the variation between. From the variation between. What the variation will be? 1 over L and 1 over R. 1 over L and 1 over R. 1 over L and 1 over R. As mentioned under theory. Right. And we need minimum of 6 values, right? By changing R, then R changes, when R changes, L changes, so we need R 1 over L and 1 over L. L and 1 over L. Right, this is in ohms, this is per ohm, centimeters per centimeter. Right. So what we need to plot the graph is these two, right? 1 over R and 1 over L. Plot the graph, 1 over R and 1 over L. Plot the graph. Right, next point. Next point. Determine simple R. Determine simple R using gradient and intercept. Determine simple R using gradient and intercept. As discussed under the as discussed under the as discussed under the right. Right, that's it. That's it. Remarks. Remarks. Right, now Horana again because they are on with the previous one. They are not right. One day. Now using this setup, we can't measure very small potential differences. Right? We can't measure very small potential differences. Right? So therefore, when we choose this cell, right? We have to choose the cell, right? Choose the cell as our balance length is falling somewhere between at least 40-60 range. Right? If there is too small or too large, right, either sides, it's going to make errors. Right? So, again, modification very small mind if you need to measure small potential differences, you have to reduce K. Right? Unless otherwise, you are going to get a very small L when measuring small potential differences. Right? For a given value, when you are choosing E, right? It should be as you are getting the balance point somewhere between 40-60 at least, right? As a first point right now, first point. This circuit is not capable of. This circuit is not capable of. This circuit is not capable of. This circuit is not capable of measuring small potential differences. Not capable of measuring small potential differences. Right. Write down the reason below. Write down the reason below. Write down the reason below. A very small balance length is obtained. 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 When measuring small potential differences. When measuring small potential differences. Hence, percentage errors are high and incorrections of potentiometer and incorrections of potentiometer cannot be neglected. Cannot be neglected. Cannot be neglected. Cannot be neglected. With respect to a small balance length. Cannot be neglected with respect to a small balance length. Cannot be neglected with respect to a small balance length. Right. Next thing. Connecting this connecting this secondary loop is a must do thing, because otherwise, if we don't have this secondary loop, right, we don't have any other way to activate this arm, right? Now, when we activate it, right? The whole purpose of doing this circuit is connecting the circuit like this is activating simple arm, right? Right now, next point. Connecting the secondary loop is compulsory. Connecting the secondary loop is compulsory. Connecting a secondary loop is compulsory to flow a current through. To flow a current through. To flow a current through. Capital E. To flow a current through capital E. To flow a current through capital E. At the balance point. At the balance point. To activate. At the balance point to activate. To activate its internal resistor. To activate its internal resistor. To activate its internal resistor. Right. The next thing is about this tap key. Right, tap key is the limited cure. Right now, we just need to get the reading when a current flows only, at the point when the current flows only, right? Then the tap key is used here, right? At the very point when the current flows, you can tap the key and get the reading. That's it. Main circuit here, tap key simple. Because we are using an accumulator. That's the reason. Make accumulator. This won't discharge, right? This is just a right shell. This is just a right shell. It discharges, right? Accumulator shell is five to so it won't discharge, right? Then write down. A tap key is used. 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 A tap key is used to minimize discharging of capital A. To minimize discharging of capital A. By flowing an instant current. By flowing an instant current. By flowing an instant current. When the reading is taken. By flowing an instant current when the reading is taken. By flowing an instant current when the reading is taken. Right. Now, next question. Next question. Can we use a rheostat instead of the resistor box here? A rheostat here. Our variable resistance again, our questions are but can we use a rheostat instead of the resistor box here? Bad. What's the reason? Well, to plot the graph, R should be known. R should be known. Can we find the resistance of a rheostat? You can't. Change right? You can't find the resistance of a rheostat. But here, the variable resistor is mentioned. Right? Because we are going to find R and L. Right? R than right? So only resistor box is possible to be used here. Right? Next point. Next point. A rheostat can be used. A rheostat can be used for the secondary circuit. A rheostat can be used for the secondary circuit. A rheostat can be used for the secondary circuit. Since it does not give a non-resistance. Since it does not give a non-resistance. Since it does not give a non-resistance. Right. Next. Now, when you are choosing the cell here, right? When you are choosing the cell here, right? First thing, it should be less than E naught, right? If that is greater than E naught, right? You can't get a balance point of A1 if this is greater than E naught, then it should be less than E naught. And always we are choosing the cell as the balance length is falling between 46 range at least. Right? Next point. Next point. Here is the method. No need to mention invert. Mention this way. E should be less than E naught. E should be less than E naught. Right? E should be less than E naught. And right. Now, even if E is greater than E naught, that doesn't matter if it measures the potential difference when the current flows. Right? Again, negative 2 volts with negative 3 volts. If this potential difference across this current flows is 1.5 or something, or 1 or something. Even balance even with that, I mean, this is balanced to this, right? IR. Right? Even if that is E minus IR when current flows. Right? But be on the safe side, we are using this. Make a battery party goes too much. Again, whether we can use volts battery right? 8 volts battery resistor what potential difference potential difference 3 volts right? That to some extent, maybe to some extent, we have a kind of freedom to go a little bit beyond E, right? If the potential difference is less than that value. Right? Okay. What did I say? Negative. Right. E should be less than E naught. E should be less than E naught. To get a balance point. Oh. To get a balance point. Oh. 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 Even if E is greater than E naught, or even if E is greater than E naught, or even if E is greater than E naught, or even if E is greater than E naught, if potential difference across cell is less than, if potential difference across cell is less than E naught, still the balance point can be obtained. Still a balance point can be obtained. Still a balance point can be obtained. Right. Then the reason we use the accumulator is very much same as before, right? Yeah, no, same. Next one, accumulator is used to provide a steady current for a longer period of time. Accumulator is used to provide a steady current for a longer period of time. Right. Next one. Right. Here, my last day here. If you need to check whether accumulator is discharged at the end of the experiment after taking all these 6 readings, right? According to your question. Again, to check whether accumulator is discharged, take the first reading again. Just capital R to the initial value and take the first reading again and compare it with the initial value. Right? Next point. Take the initial reading again. Take the initial reading again. Take the initial reading again. At the end of take the initial reading again. At the end of take the initial reading again. At the end of the experiment. Take the initial reading again at the end of the experiment. Take the initial reading again at the end of the experiment. To make sure whether the accumulator is discharged. 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 Right. That's it. Any questions? Any questions? Now check what we have done from the beginning, and with this we mark the end of electricity practicals. Right? The electricity here, right? Now after this, I'm going to take the properties of matter. Right? Check electricity experimental right? Exactly how these 4 electricity experiments we discussed. Right? You can ask anything before we move on to the next. Right? It was electricity. It was electricity again. It was a properties of matter. It was the modulus surface tension. Right. Check all of them and ask the questions. And if there is clear, say it's clear online. Right? Anything? Right. Right. Anything? Yeah. One second. Lagi saya mau Listen. Right, listen. 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 There is a good question. When we listen, when you draw circuits, right? As the symbol of any switch, this can be used, right? This does not mean that this is the standard symbol of any switch, any type of switch, huh? Any type of switch. One switch symbol, right? One battery kind of make a accumulator. Accumulator looks like this. Accumulator looks like this. Right? The any symbol there. But when it comes to the cases where you have both tap keys and plug keys, to identify between tap keys and plug keys, right? You can draw plug keys like this, right? That is fine. And even if you draw it like this, that is also fine, right? Make it out of the that is fine. Right? And this is used for the identification purpose, right? That is for the identification purpose of plug keys and tap keys, right? If not, as an overall, any key is drawn like this, right? Right? That may switch like a symbol. This is not a symbol of a switch, right? This is just a symbol used to identify a plug key, right? Anything else? Right? Hello. Anything else? Right. Then let's move on. Everything. Last. Right then. Okay. Right. Listen. So this is the end of all electricity experiments. This is the end of all electricity experiments, right? And there are two more experiments that is probable to come, right? That is probable to come as a structure is a under is a one structure is a one, right? These two are from properties of matter, right? Properties of matter. Now, I'm planning to discuss these two experiments from properties of matter because I don't need to leave it behind without discussing, right? Question and answer Young's modulus Young's modulus has come like 2 times zero in the history, right? History of Young's modulus has come 3 times. 3 times in the history. History again for like 4 years. And 3 times again. And Jaeger's method, right? That is the experiment on surface tension, has never been found. Right? So that can come as a result any direction. Right? Papers are on right? Papers are on right? So therefore, I'll be discussing those two as the last two experiments here, and after that there will be the end, right? Or make it these properties of matter, right? These properties of matter. Properties of matter. Right. So go to experiment 5. Right now, determination of And determination of Young's modulus of a steel wire. 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 Young's modulus of a steel wire. Right. Listen, right. First, we have to have right two wires made of the same substance. Right. First, we have to have two wires made of the same substance. Right. Two wires made of the same substance, and both wires are going to suspend here at the same supporter. Right. Same supporter. If that is at the ceiling, then it will be close to each other at the ceiling. Right. It is suspended. Then this is the first wire. Right. Here we have suspended. Suspended. And for this wire, right? For this wire, a fixed mass is attached. Right? A fixed weight or fixed load is attached. Right? Fixed load is attached here. And for this wire, right, we connect the main scale. For this wire, we connect the main scale. We connect the main scale for this wire with the fixed mass. And this is the next wire that is next to this, right? Next to this, that is made of the same substance, right? Made of the same substance. And for this, the tray is also attached because we are going to change the load, right? The tray is also attached because we are going to change the load, right? We are going to change the load. Tray is also attached, right? And for this, a vernier scale is fixed. For this, a vernier scale is fixed. Right. Okay. Now this is a main scale. This is the main scale. This is a vernier scale. Right? And this one is a fixed load. Fixed load. Right? And this is the variable load that we are going to change. Variable load. Right. Now, listen. The reason to attach a vernier scale and main scale is when it comes to extensions, they are comparatively very small values. Right? Since they are small values, right? To take that reading accurately, vernier scale is attached. And main scale is millimeters. Vernier scale is divided into 10, then the least count is going to be 0.1 millimeters. Right? But we can go with the higher accuracy as well with the required millimeter. Right? Unless otherwise, this is a millimeter scale, main scale is a millimeter scale, and vernier scale is divided to 10 divisions. Right? And then after adding a weight here, right? Before adding any weights here, first you have to take the initial reading. Before adding any weights here, right? When this is empty, first you are taking reading, right? And then adding weights, and when we add weights here, we are adding 500 grams weights at once because they are steel wires and it needs kind of a higher load to extend, right? So they are 50 grams, 100 grams, right? Minimum we had 500 grams at once, right? Half kilograms, 0.5 kilograms, right? At Kerala. Then you take the reading again from the main scale and vernier scale. Reading again, and that second reading minus initial reading is the extension of this wire, right? Because this won't be extended the way that is a fixed load. It won't be extended, right? Calculation purposes. This is to compare this with this when taking readings, right? And we are going to do the calculation based on this second wire, right? Then from Young's modulus we know, F over A equals Y times E over A, right? Now, if the initial length of this wire is L, right? The initial length is Metre, right? Say that is capital L. F is here, right? F is here. When this rate is mg, right? Say the diameter of the wire is d, then phi r squared dO squared y e can be taken from this over L. Now from this one, what we can change is m, right? When m changes, what is going to change from the other side is extension. L is a constant, y is a constant, diameter is a constant, y constant, d constant, right? Then when m changes, e changes, right? Then m is going to be used as the independent variable, right? Subject m. Now this is mg equals, right? Phi d squared and then the y e over L, right? Then equals 4gl, right? Equals 4gl over phi d squared y, phi d squared y. Right? Now we can draw a graph between this and extension. And the graph is the y percentage between E is in millimeters, right? Then mass is in kilograms. Gradient of graph is OGL over phi d squared y, right? Now 4 G is known, L initial length can be found, right? To find initial length, you can use the meter rule, right? Initial length is a lengthy one, like a vertical scale one, right? This can be like 4 meters, 5 meters, whatever, yeah. Because when we take a lengthy wire, extensions are also significantly increasing, right? That's why otherwise, extension then that's it. So length can be measured using a meter ruler. Phi is known. D, diameter of wire. To measure diameter of wire, they are using a modulus 2 gauge. To measure diameter of wire, then if everything is known, right, using gradient, y can be determined. Right? Y is something there now. So y is make gradient m dash, say that is m dash, because I used m here already. Right? M will be dash here now. Then y is given by 4gl over phi d squared m dash like this here 0.5. Right? Make an experiment about that, but the background that you need to know about the experiment is, right, a little bit more. Right? They have used again our benefits product theorem. Right? They have used again benefits product theorem. Right? Again, now sometimes when this is loaded, right, this point will be static. Right? Then we have this is going to stack here. Right? Even if there is set, when both are there, both are going to go down. Right? Then those cells are minimized. Right? Those cells are minimized. And if there are changes of length due to temperature increases or temperature, when you do this in the environment, what is happening? Right? Then both extends together, then there won't be any error coming into the calculation because of linear expansivity. Right? Benefits here. They are the vernier scale, main scale, and they are using two for different other readings, different other reasons. Right? We'll see them in the next part. Right. First, mention the materials. Right? On the materials, mention the materials. Mention the materials again. Okay, mention the materials. And 2 into 4. 2 into 4. 2 into 4. Steel wires. 2 into 4 is steel wires. two uniform steel wires within brackets about 3 meters long, about 3 meters long. Length of the range and lazy about 3 meters long. Height 3 to 4 meters, about 3 to 4 meters long. With a diameter, about 0.5 millimeters. With a diameter about 0.5 millimeters. Right. Next, main scale calibrated in millimeters. A main scale calibrated in millimeters. A main scale calibrated in millimeters. Next, a vernier scale. Next, a vernier scale. A vernier scale. Then a pan. A pan. A pan. Then a set of 0.5 kilograms weights. 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 Right? Then a meter ruler. A meter ruler. A meter ruler. A micrometer screw gauge. A micrometer screw gauge. Right. Alright. Then and the apparatus, take it down. Apparatus. Right, pan. No, this is the pan. This is the pan. And this is the supporter. Right, here. There is a long yard. Supporter. And you will be getting two questions from modulus and Jaeger's method in next two papers coming up. Right? This is Horana record. Here I have on the work. What is that? No, Bayar na smoke na kari. Sound lagi lagi. Yeah, we can do it. Okay, take out. Hello, cool, like that. Support a main scale, vernier scale, fixed load, fan, variable load. Hello. Right, finish. Have it. Have it. Okay, then theory. Theory. Write down. Write down. If suspended mass is, if suspended mass is, if suspended mass is symbol M. If suspended mass is symbol M. An extension of an extension of an extension of the wire is an extension of the wire is extension of the wire is symbol E. Right, put it on and start from here. Start from here and measure it up to this point. Oh. There. Now, like that. I don't know which I didn't. I got only 28 days. Like 8:30 a.m. just after 28 days, right? You are ready your events, right? And why you are ready 8:30 and 1:30, you are ready 5 hours. Right? Huh? Okay, other. Okay, next. Okay, let's go to method. Right. Discuss another, let's go to method. I know method. Method. First one. First one. Suspend two steel wires. Suspend two steel wires parallel to each other. Suspend two steel wires parallel to each other. Suspend two steel wires parallel to each other from a same horizontal supporter. From a same horizontal supporter. Right. Label these two wires as A and B for the ease of explaining. Right. Then I label these two as A and B. Right. Label these two wires as A and B. Label these two wires as A and B. Right. Next point. Suspend the fixed mass, fixed load. Suspend the fixed load. Suspend the fixed load. Suspend the fixed load to wire A. To wire A. As it is well stretched. As it is well stretched. As it is well stretched. Next point. Next point. Connect the main scale. Connect the main scale. Connect the main scale. Connect the main scale. To wire A as shown. To wire A as shown. Next, attach a pan, attach a pan to the end of wire D. Attach a pan to the end of wire D and connect the vernier scale and connect the vernier scale. Within brackets, attaching the vernier scale closer to attaching the vernier scale closer to bottom end of the wire B, bottom end of the wire B is more convenient when finding extensions. Right. Next point. Add a mass of 0.5 kilograms to the pan. Add a mass of 0.5 kilograms. Add a mass of 0.5 kilograms. Add a mass of 0.5 kilograms to the pan. And take the reading and take the respective reading using scales. Within brackets, the difference between final reading and initial reading. The difference between final reading and initial reading. The difference between final reading and initial reading. The difference between final reading and initial reading gives extension. The difference between final reading and initial reading gives extension. Right. Next point. Keep adding weights. By 0.5 kilograms. By 0.5 kilograms each. By 0.5 kilograms each. And repeat the experiment. Repeat the experiment. Right, listen. Right now, while recording, now while we are adding the weights, now you have got the readings of the extension, right? And we are not going to end the experiment just after taking 6 readings by adding weights, right? Then what we do is we are removing the weights again and getting the readings again, right? Remove the right? The reason is to have a more accurate value for extension, right? And if there are any bends in the wire, some are bends, very nice because this is a thin wire. Since there is a thin wire, right? If there are bends in the wire, sometimes when the load is added, the bends are stretched, right? The bends are getting straight. Right? They have bigger wire, they are become bigger. Now in the wire, right? Then the wire will be here. Right? We're binding wires and everything. Now, when the load is there, these are going to combine the stretch. Right? Then to minimize such errors, right, we are unloading the system as well. Right? Load kara the bigger no, just unload. Hello. That's like what here. Unloading never going Saka while when you are unloading, you are getting a difference in the initial rate. Come higher. But again, may walk a window. I mean, then the other thing is finally you can make sure that wire B is still within the elastic limit, right? Whether it has exceeded the elastic limit, because if it has exceeded the elastic limit, when you are adding weights, right? Which means the whole experiment is wrong because Young's modulus is valid only up to elastic limit, right? Young's modulus is valid only up to elastic limit, right? Now in the when this returns back to the initial position, right? Initial reading will be approximately equal with the initial reading that you have taken before, right? If yes, which means that is within the elastic limit, right? Then you have to replace by and do this again, right? If you have exceeded the elastic limit. Okay, then next point. Repeat the same. Repeat the same. Repeat the same. Repeat the same. By removing the added masses. By removing the added masses. By removing the added masses. One by one again. By removing the added masses one by one again. Right? Next. Calculate the average value. Calculate the average value. Calculate the average value of extension. Calculate the average value of extension. Obtain when loading and unloading. Obtain when loading and unloading. As the final extension. As the final extension. Right. Now, this is how our variable looks like. Right. This is how our variable looks like. Right. Masses are here. Right. Masses are here. And the scale readings, right? When it comes to scale readings, right? Again, we have two when adding masses and removing masses. Adding and removing. Right. Say these masses are initially 0, 0 means when only the band is attached. When only the band is attached. Right. Then 0.5, 1, 1.5, 2, 2.5, 3. Right. Likewise, minimum 6 reading we need. Minimum 6 reading we need. And if these readings are known, right, now we can get the extensions. Extensions and two extensions also, right? Extensions. Again, when adding and removing. Right? As an example, there is R0, right? R1 dash, we have reading R1, R1 dash, and extensions E0, E0 dash, E1, E1 dash, and E1. And this is the average extension. Average extension. Right. When again, they will load. Right, take down. Right, take down. Mass scale reading, mass scale reading, adding, removing, extension, adding, removing, average extension. There, mass scale reading, adding, removing, extension, adding, removing, average extension. Mass scale reading, adding, removing, extension, adding, removing, average extension. Right? Right? So at the end, what we need is average extension. Alright? Alright. How calculation can be done? Somehow we diameter. Diameter also. Alright? Next point. Next point. Take diameter. Take diameter. Take diameter. In two perpendicular directions. In two perpendicular directions. In two perpendicular directions. At three different places. At three different places. Two perpendicular directions. Two perpendicular directions. At three different places. At three different places. On the wire. On the wire. And get the average. And get the average. And get the average as final diameter. And get the average as final diameter. And get the average as final diameter. Right. The final diameter is d1 plus d2 plus d3 over 3 in this. Right. Next point. Measure the length of wire. Measure the length of wire. Measure the length of wire. Measure the length of wire using meter ruler. Using meter ruler. Measure the length of wire using meter ruler. Right. Next. Plot the graph. 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 Between E and M. Between E and M. Between E and M. Between E and M. and find its gradient 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 and find its gradient. Next point. Calculate y. Calculate y. Calculate y. Calculate y as mentioned under the 8. 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 Right. So that's it. But there are like other minor things, but the important things to discuss. Right, our remarks. Like experiment there, you are sitting here at all with other remarks. Right. First of all, thin wires should be used. Thin wires. Thin wires should be used. Thin long wires, thin long wires should be used. Thin long wires. Thin long wires should be used. Should be used to get a considerable extension. To get considerable extension. To minimize fractional errors. To minimize fractional errors. Fractional errors. Right. Next one. Both wires should be fixed together as parallel to each other. Both wires should be fixed together. Both wires should be fixed together. Both wires should be fixed together. Parallel to each other. Parallel to each other. Right. Next point. Next point. Following benefits are they are when using two wires. Following benefits are there when using two wires. Right. Under that first one. Errors due to sagging. Errors due to sagging / yielding. Errors due to sagging / yielding. Sag වෙනවා කියලා දන්නවනේ. right? මෙහෙම වෙනවා කියන්නේ sag කියලා. මේක මෙහෙම වෙනවනේ කියන්නේ sag කියලා. Sagging. Errors due to sagging and yielding of the border are minimized. Of the border are minimized. Right. Next point. Errors due to linear expansion. Errors due to linear expansion of wires when temperature changes. Are removed are eliminated. Right. Next point. Extension should be taken while loading and unloading. Extension should be taken while loading and unloading. Extension should be taken while loading and unloading. Through that, following experimental errors can be identified. Through that, following experimental errors can be identified. Through that, following experimental errors can be identified. Right. First one, right, mention one by one. Right, there are errors here. First one. If they ask, any slip, SLI slip slash displacement. At connecting points of wires, and scales, wires and scales. Next one. If there's any bend, is straight. If there's any bend, is straight. In the wire. Next one. No. Can make sure if the wire is within the elastic limit. Can make sure if the wire is within the elastic limit. Right. Next point. If there's a sudden change, of extension, if there's a sudden change of extension, is noticed when taking readings. It can be due to straining a bend. It can be due to straining a bend. Straining a bend. Can I mean, don't tell they don't have any. Bends කියන්නේ මේ වයරේ පේන්නේ නැහැ. එයා තියෙන වයර්ස් නෝ. මේ වයර්ස් වල මෙහෙම පොඩි බෙන්ස් තියෙනවා. මෙහෙම කොහොම බෙන්ස් තියෙනවා. right load ගන්න මේ බෙන්ස් ටික. right ඒතකොට extension එක අන්න ගාලා fine. hello otherwise extension is linearly varying. right අපිට තේරෙනවා extension එක යන්නේ කොහොමද කියලා. when there is say 1.5 වලට 1 millimeter for 1.5 2 millimeters මේක 3 millimeters ඔහොම යනවා. එතන කොහොමද එකපාරට 6 වගේ වෙනවා. අන්න බෙන්ඩ් එක දිගයි. right next point. If fire does not returns, if fire does not returns, back to its initial length, returns back to its initial length. After removing all weights, elastic limit is exceeded. Within brackets, have to redo within brackets, have to redo the experiment. With another, new wire. and we'll do the experiment with another wire. Right. That's it about Young's modulus. Any questions? Right. What do you experiments? I then again note. Any questions? Quickly. Data are on the other way. Any questions about Young's modulus? Any questions? Never I am going to say no. Okay, is it clear? Any questions? Right. All good. All right. Okay. Then online. Are you all good? Online. Are you all good? Right. Then let's go to convocation. Done. Alright. Okay. Experiment 6. Okay. Right. Determination of surface tension of liquid. Determination of surface tension of liquid. Determination of surface tension of liquid by Jaeger's method. Determination of surface tension of liquid by Jaeger's method. Determination of surface tension of liquid by Jaeger's method. Right. See? Jaeger's method. Right. Now I think it. Listen. These are flask. These are flask. Right? These are flask. And here this is a funnel with the tap. This is a funnel with a tap. This is a funnel with a tap. Right? A funnel with a tap. Right. Right. And to this end, the capillary tube is connected. To this end, the capillary tube is connected. Right. And here we have a manometer. Manometer. Manometer is a pressure gauge. Manometer is a pressure gauge. Manometer is a pressure gauge. Right. This is a manometer. Manometer is a pressure gauge. Right. And here, this is the liquid that we are going to which we are going to find the surface tension of, right? And here we have a bent pin, right? There is a bent pin, and here, right? We have to have an adjustable table, right? Height adjustable table. Adjustable means height adjustable table, right? Height adjustable table. Height adjustable table. Right. So, funnel with that. Funnel with a tap. Right, and this is a flask. This is a flask, right? And this is the manometer. Manometer is a pressure gauge. This is height adjustable table. Height adjustable table. And this is a bent pin. Bent pin. Bent pin. Right? And this one is a capillary tube. Capillary tube. Right? So in the manometer there are second liquid, right? They have liquid that here, that is for the manometer liquid. Right? This is manometer liquid. Right. Let's consider height difference of the manometer liquid is simple H and density of the manometer liquid is say sigma. Right. Height D. Height difference of the manometer liquid say D. And height to the bottom of this from here say H and density is rho. Right. Now listen. Oh. That's okay. Okay, listen. Listen. Okay, listen now. Jadi kan? Listen. He's a competitive. He's a competitive. Right? Competitive. And here, before we insert this tube into this liquid, a bent pin is attached here. A bent pin like that. A bent pin. Right? Is attached. Right? Here we are. Rubber band we attach that to here. And then height of the table is adjusted until this end of the rubber tube is immersed in the liquid. And as the bent pin just touches the water surface, what I mean, the liquid surface here, right, in the vehicle. I make a touch and I make a just right. And now we have a confined air inside this tube. See, we have a confined air inside this tube. Right? We have a confined air inside this tube. Right? In the end, right. We have confined air inside this tube. When the tube is confined air, that is not open to atmosphere. Right? Now, what we do is we are opening the funnel. Right? When funnel is open, these four droplets from the funnel are adding with this one. Right? When it is added, volume of water increases. When volume of water increases, volume of the gas medium decreases, so pressure increases. Right? It is going to increase pressure. Then this pressure is right transferred to here and here as well. Right? Because of the additional pressure, then pressure is volume increases. When that volume increases, volume increases, volume of water increases, volume of gas displaces, it decreases, and it displaces toward this side. The gas molecule, then this will be pressurized. When there is pressurized, there is a liquid meniscus forming here. And you know the liquid meniscus happens. Right? If you take an enlarged view, right, a magnified view, right, make a view better. Now at the edge of this tube, right, there is a liquid meniscus formed like this. Right, combining over movement, right, combining over movement, now it will be initially like this, and then radius gradually decreases, and it is reaching its maximum. It is reaching its maximum, right? When radius of meniscus equals radius of tube, right? अन्य point करें ना, अन्य देखो पूरा दी देखो meniscus है, ये बस नहीं है, मेरा radius का reduce हुआ ना, ये लगी ये ना, यहाँ एक point take करें ना, right? That point is maximum point take ये नहीं होगा, so at the maximum point, it looks like this. At the maximum point, since radius of meniscus and radius of tube are equal, the meniscus is exactly hemispherical, and the meniscus is like this. Meniscus are there. Right? And if you increase pressure further, this liquid meniscus is going to explode. I don't know. That is going to break, that is going to explode. But pressure, why do you know? Because it is going to counterbalance pressure by it equals 2 DOR. Meniscus is 2 DOR. Right? 2 DOR, if that pressure is not bearable, that is going to explode. What explode? Right? Explode is then I may liquid right. Now, by slowly adding water into the flask here, right? We have to obtain this occasion where the maximum pressure difference occurs the pressure is right. A maximum makeup it breaks. Right? If you just go beyond the maximum point, it breaks. Right? Maybe identify because for the first time you are going to get this advance, right? It explodes. When it explodes, we have an idea what was the difference of levels, liquid levels in the manometer. Then we know that this is going to explode somewhere around 4 centimeters. Then when that is closer, we are slowly releasing this and identifying this scenario. Right? Right. Let's assume pressure inside the meniscus as T1. Right? Pressure inside the meniscus as T1 and atmospheric pressure as P0. This is open to atmosphere P0. This is also open to atmosphere P0. Right? If pressure inside the meniscus is P1 and if pressure outside the meniscus is P2, right? To write pressure inside the meniscus, you can get into the system through the manometer, right? P0 plus D sigma G, right? But D sigma G equals pressure at this level. That is equal to same horizontal level. That is equal to this medium here up until here. Right? And rubber band up until here. Right? Then P1 is P0 plus D sigma G equals P1. Pressure inside meniscus. To write pressure outside meniscus. Outside meniscus can name. Right? Then P0 plus simple H rho G. Then P0 plus simple H rho G equals P2. Right? Here we are. Now we know pressure difference across the liquid meniscus. Pressure difference across the liquid meniscus delta V is given by 2D over R. Right? Pressure difference is pressure inside minus pressure outside P1 minus P2. Then P1 minus P2 equals 2D over R. P1 is here. Right? P0 plus D sigma G minus P0 plus H rho G. Right? Equals 2D over R. P0 to P0 cancels. Right? G is common. Then D sigma minus H rho equals 2D over R. Then T is given by GR over to D sigma minus H rho. Right? G is known. Right? R is now equal to radius of tube. Radius of tube should be determined later on. Right? Using a traveling microscope. Right? Traveling microscope का use करला अराडो हुआ करने लो. Okay, well, using a double microscope, later on we have to find the radius of tube, right? Take a Horana column. G is known, right? G is known. Take a Horana column. D, density of anomaly liquid is, sorry, height of anomaly liquid is known. Density of anomaly liquid is known. These two are known. This means they can be done, right? This is the most accurate method to find accurate, and there are some other lyrics also to find surface tension of liquid, right? This is not only limited to these kind of liquids, right? Even for something like mercury, this is also still possible, right? Right. Material special right? Right. Okay, first mention materials. First mention materials. First mention materials. Materials. Right, mention. Jaeger's apparatus. Jaeger's apparatus. Jaeger's apparatus. Jaeger's apparatus. A beaker. A beaker. A beaker. Then a small amount of kerosene. A small amount of kerosene. Kerosene, that's not one. A small amount of kerosene. Kerosene no water. Huh? What's the color of kerosene? Huh? Red. Right? See that one? Blue here, blue here, blue here. Come on, green, green. Red team there, blue here, blue here. Blue here also. Right? Okay. Then the liquid of which, next one, the liquid of which surface tension to be determined. The liquid of which surface tension to be determined. Then traveling microscope, a traveling microscope, a traveling microscope, a traveling microscope. Next, funnel with that. Funnel with that. मैं funnel लेके बोलना टर्म ले उठते हैं ना बहुत टर्म है और उसका आप जो क्या visual funnel dia lagi apa kira di mana oh nanti visual funnel dia ada ulang right funnel with that for funnel with that right then height adjustable table 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 height adjustable table. Okay, now take out the apparatus. Take out the apparatus. I don't want to put a carry. Right? I don't know. Face it. Apparatus can I have. Jadi apa baik dia kan? Sampai aja. Ya, dulu. Ya. Terus, ya kan? Baik. Saya balikan dia kan? Oke. Kalau dia ini, jadi, itu. No need to draw this here. Megan No need to draw this here. Right. Here. Right down. Let pressure inside. Let pressure inside. Meniscus. Left pressure inside meniscus. BP1. BP1. And that outside. And that outside. And that outside. P2. And that outside P2. Right? P1. Right. Put it on. And start here. Start here. From here. Start from here. Start from here. And let's say up to here. Very good. Okay, then method. 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 First point, find out. First point. Capillary tube should be very clean. Capillary tube should be very clean. Capillary tube. Capillary tube should be very clean. Capillary tube should be very clean. Right. What are the steps of cleaning a glass tube? washing with sodium hydroxide, then HCl, then distilled water, and well drying. Right, taste the other here on substantial game over here. Right, 28 days. Substantial game over here. Right, mention these four steps. Right, first one, wash with sodium hydroxide. Base scale we have to mention the base. Right, wash with sodium hydroxide. Wash with sodium hydroxide. Second one, wash with HCl. Wash with HCl. Third, wash with distilled water. Wash with distilled water. Distilled water. Four, well drying. Well drying. Well drying. Well drying. Right, wow, maybe more easy. Now, have I considered any angle of contacts? No, this is very clean. Then we can make sure that there is no angle of contact here. Right, I can the angle of contact है Right, next point. Next point. Bend a pin. Bend a pin. Bend a pin. Bend a pin. Bend a pin and attach it to. And attach it to. And attach it to. Attach it to. Capillary tube as shown. And attach it to capillary tube as shown. Attach it to capillary tube as shown. Right, within diagrams. Around 3 centimeters above. Around 3 centimeters above. Around 3 centimeters above. Around 3 centimeters above. Right, next point. Fill the beaker. Fill the beaker. Fill the beaker with the liquid. Fill the beaker with the liquid. Of which? Fill the beaker with the liquid of which? Capital T to be determined. Capital T to be determined. And keep it on. And keep it on. And keep it on. Height adjustable table. And keep it on. Height adjustable table. And keep it on height adjustable table. Right? Next point. Adjust the height of table until. 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 Bend pin. Bend pin. Bend pin. Just touches. Just touches. The top surface of liquid. Just touches the top surface of liquid. Just touches the top surface of liquid. Just touches the top surface of liquid. Next point. Open the tap. Open the tap. Open the tap. And let water falls into the flask. Open the tap. Open the tap and let water falls into the flask. To increase pressure inside system. To increase pressure inside system. Do this until the liquid meniscus is exploded. Do this until the liquid meniscus. Do this until the liquid meniscus is exploded at the end of capillary tube. at the end of capillary tube. Right, next. Repeat again. Repeat. And identify. The occasion when. Identify the occasion when. Pressure is maximized. When pressure is maximized. And get the respective. Height difference of phenomenal liquid. Respective height difference. Within bracket simple d. Respective height difference within bracket simple d. Of manometer liquid. Right. Within brackets. Can repeat again and get the average value. Can repeat again and get the average value. For more accurate reading. Right, and DM sigma is known, right? The other thing is finding H known, right? HRMI to find H, right? After doing the experiment, you have to remove this beaker, right? Beaker in there. After removing beaker, right? We are posing the traveling microscope to the bottom end of this pin and taking the reading, right? The pin focus and taking the reading, and then it is focused again to the bottom end of the capillary tube and taking the reading. Difference between these two is the height here. Pin right? Pin order when height that's why the pin is connected. Like I was saying, making these readings because due to refraction there will be errors. Focus otherwise, if you try to focus the microscope through this hole here, right? There are errors of the reading due to refraction, right? Right? Then once this is removed, we have a very setup. Right? After everything is removed, then focusing microscope here and taking the reading, right? And focusing into the edge of the table, edge of the tube, and taking the reading. And difference between these two is the height here, right? Take a microscope. And not only that, we need the radius also. Radius diameter also. Then to find the diameter also, right? We have to fix this in front of the microscope and get the internal diameter. That's what microscope use. Right? Then remove the beaker. Remove the beaker. And focus traveling microscope. And focus to the bottom of bent pin and take the reading. To the bottom of bent pin and take the reading. And to the bottom of capillary tube. and to the bottom of cumulative and take the reading. Difference between these two gives simple H. 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 Right. Next point. Next point. Fixed cumulative. Fixed cumulative. Fixed cumulative in front of fixed cumulative in front of covered microscope horizontally in front of covered microscope horizontally in front of covered microscope horizontally and get the internal diameter right. Take that in mind. To get internal diameter, right? First you have to focus the cross wires here. Take the reading, say R1 to here, R2, right? It was made up of that. Then to here, say R3, and to this point, say R4, right? Vertical diameter is right. Vertical diameter is B1. Vertical diameter is R2 minus R1 minus R2. Horizontal diameter is R3 minus R4. Right? Then diameter of this tube is D1 plus D2 over 2. Take this down. Right? Diameter of Horana told. But where is it made? Right? Next point. Calculate. 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 Capital T. Calculate capital T as discussed under the calculate capital T as discussed under the calculate capital T as discussed under the right. That's it. Right. And remarks. Remarks. Right. Remarks. Okay. Right. Remarks. Remarks. First point. This method can be used to. This method can be used to. This method can be used to study variation of surface tension with temperature. This method can be used to study variation of surface tension with temperature. With a relevant modification. What modification है? Whether the Pasindu Sandaruwan can check करा or not make a different temperatures वगैरह if you need to find these at different temperatures, T at different temperatures, right? Using a Pasindu Sandaruwan, we can do the same, right? We can do the same. There are variation in surface tension other T and theta, right? Decreasing in the increasing rate, right? sorry, decreasing and increasing rate, and variation in variation. Right. And next point. A liquid with lesser density is used for manometer. A liquid with a lesser density. A liquid with a lesser density. A liquid with a lesser density. Within brackets, like kerosene. Kerosene on density is 700. Right? Like kerosene. To get a considerable height, to minimize percentage errors. Right. Next point. Capillary tube should be well cleaned. Capillary tube should be well cleaned. Capillary tube should be well cleaned. As to neglect, angle of contact, and make the liquid meniscus clean. And make the liquid meniscus clean. Okay. Right. That's it about Jaeger's overload. Any questions? Right. Then I did these two for a reason. Right. Last two I did these two for a reason. Right. And I got right. Last two. Any questions from anything we discussed today? Any questions? Anything? The last night seminar. You are heading for the events, right? Pasti awak kan naik ini. Pasti kan. Jadi naik apa? Itu lagi nanti naik. Okay, tengah ada kira-kira tak ada. Anything? All right. Any questions? Right. Right side I got the other. Already got the other. Any questions? Our ID facts are. Okay. Anything? All good. Will you include questions for these two in favors? Yeah, I will include. Right, I will include, right? About the elevation. Right, will include. Anything else? No, okay. All good. Okay, then that's it. It's a wrap about practical also, right? Around seminars, right? These are last practical seminar I conducted, and starting from mechanics one, right? Starting from mechanics, waves, optics, thermal, electricity, right? In these two, right? These seminars, 5 seminars, covered all the practicals that you need to know for the exam, right? The practical and I was publishing the TIMP videos also in the last days, in recent days. So you do check if needed. Seminar videos everything can 6 hours, 7 hours, 8 hours long in the but for videos that upload by the way of the upload done here. Right, separate. So now these are upload color the right. Then that's it. So exactly 28 days from here, right? You are going to start writing your life story. Start the main milestone you have in your life, right? Our writing milestone in university, they were completed now again. Again, exam is here, right? The exam is not but that is not as competitive as A-levels. You competition like that's the thing. A-levels that's the competition like good credit. Right? You can mention a more tension like this. Right? The exam stage, right? You come pass around like that. Right? The leaders are all right now. But the thing is, competition is less and that is kind of manageable. You can never mind. When it comes to university, like we are doing a final exam only by a semester, only by the content that we have covered during a semester. Semester is only 14 weeks. 14 weeks like how exam again. Make everything is like 135 weeks. 2.5 years. 135 weeks in a year. And you are writing this during 5 hours for the subject. You are learning physics for 2.5 years and writing it only for 5 hours. Right? How do they have our background here? Simple as that. Right? They are competition. They are competition. The exams are not there. They are difficult, but the thing is manageable. 14 weeks ago, we learned 2 hours, 3 hours, yeah, no, right? Study leave again, go down, study leave again 2 weeks, right? Or 14 weeks, 2 weeks, exam. Right? The thing is A-levels, right? A-levels are point. That's a turning point. That's a turning point of the life. Milestone. Right? Then work out, right? Just 28 days. Yeah, hours studying other one around 600 hours. Right? Again, in date 10, around 600 hours, 650 again. 650 hours. Right? 45 hours then. I think you know I read it. And balance all three subjects, right? Balance all three subjects, right? Then right? Manage papers and manage your things by your own, right? Manage subjects. Subjects are weak points, but again, now it's beyond the guideline, right? Prioritize subjects, prioritize without harming others. ගොඩක් අය මිස්ටේක් කරනවා අන්තිම වැඩ කරන්න ගියාට පස්සේ මොකක් හරි වීක් එකක් අල්ලගෙන වැඩ කරනවා අර අනිත් පොඩ්ඩක් හොඳට තිබ්බ සබ්ජෙක්ට් එක අතට ඩ්‍රොප් කරනවා ඒක හරියන්නේ නැහැ right එහෙම prioritize කරනවා if you are prioritizing a weak subject it should be prioritized without harming the other two right and especially for ICT ones it's better if you can finish off everything now like before 1 month to the exam ahead 1 month of the exam. Right, because for ICT after physics second paper, you will have another like around 9-10 days only for ICT. Right? I know days here. 14, physics second day 17, ICT must take us 20, 8, 8, 8. Ah, for chemistry? 24 chemistry. 28, so you have 10 days, right? The 10 days, use that is an advantage. You can take it to ICT. ICT can take a syllabus. Right? Then you can prioritize other two subjects and then get back to ICT after 17. After 17, right? And for the combined maths and bio ones, there's no chance like that. Right, you are going to finish off all these subjects just in 12 days. Right? 10 days, 24 with the 14. 14 days, you right? 24 with the subjects here. Right? 10 24 with the subjects here, right? Just in 14 days. Right? So I think already right. Then listen. Listen. Hello, get manage and write as much as possible number of papers, question types, right? And practice those questions by your own, right? Paper last paper එක weekly වෙනවා කියලා නිකන් ඉන්නේ බාවද? එකයි කියන්නේ, right? homework paper එකක් දානවා. එතන ලියන්න ඒක දෙකයි. ඊට පස්සේ past paper plan එක යනවා. ඒකේ past paper එක යනවා. එතකොට ඒක තව weeks දෙකක් යනකම් continue වෙන්න ඕනේ. අන්න ඒක දිනනවා. හරි. Now provisional papers are also right. Western province එක now ඔයගොල්ලෝ and all other provinces, all other means except one province, eastern the for 8 other provinces, provincial papers out, right? And support system available is out, right? ඒක නම් මම discuss කරන්න ගත්තා. මම ඒක ඊට discuss කරනවා. And I'll be discussing some special provincial papers also in the coming up days, right? So ඒවෙම වැඩි එකක් තියෙනවා. And managing time is the main key here, right? මේ දවස් ටික managing time තමයි මෙතන තියෙන වැඩි, right? නිකන් අර transport එකලා don't spend too much time even for the transport, right? Unless that is necessary. ඒකට වෙනම කර විදියක් තියෙනවා නේ එහෙම දැනෙන්නේ හොඳයි. ඒ වගේ ඉතින් තියෙනවා. And if you got anything to clarify from my side, you can contact me anytime through WhatsApp, right? So that's it. Work hard, right? මේ time එක තමයි මේ ඉතින් investment එක හොදේ. You are going to invest for like 30-40 years hereafter during this time, right? Over the investment, right? After 5 years of this point, right? After 5 years, now you are 90 years of age, right? At 24, when you look back, if you like read it for what you did in A levels, right? That is not what it is expected to be. That's it, right? වාඩේ ඉඳලා නම් අපරාධ මොළේ මෙහෙම කරන්න දීපේ දවස්වල කියලා. ඒතකොට ඉතින් මෙතනම වැඩේ කරන්න. right? එහෙම වෙන්න බෑ. right? Whatever you should do with the satisfaction, right? I know that different students has different age levels, right? Age levels, intelligence levels, like ඒකේ potentials ඒ ඔක්කොම different තමයි. හැමෝම එක විදිහට perform කරලා ඒ වෙනවා exams කියලා එකක් තියෙන්නේ නැහැ. හැමෝටම එන්නේ නැහැ, මොනවද වෙන්නේ නැහැ. හැමකටම ratio එකක් තියෙනවා, right? But you have to make sure that you have done this, you have in this game with your maximum potential. That's it. right? එහෙම කරාට පස්සේ ඔයාලා ආයි ඒකේ බොරි වෙන්න දෙයක් නැහැ. ඔයා දන්නවා ඔයාගේ maximum එක ඔයා කරලා ඉවරයි කියලා. Say you got නිකන් හිතලා 3Ds, right? ඔයා 3Ds ගත්තා. But if you know that that's your maximum, right? එහෙම ඔයාට මේකේ confidence එකක් තියෙනවා නම් කිසිම වරදක් නැහැ. හැබැයි ඔයාට confidence තියෙනවා නම් you could have get 3As but you have ended up getting 3Ds. අන්න එතන තමයි අර මම කියපු point එක. Which means you haven't used your potential, utilize your potential to the best, to the fullest. right? එහෙම වෙන්න දෙන්න එපා. එහෙම වෙන්න දෙන්න එපා. වාගේ level එකේ maximum එකෙන් වාගේ වැඩේ කරන්න. right? එහෙම නායි වෙන්නේ. right? ඒක හැමෝටම කරන්න පුළුවන් දෙයක්. but the thing is, right? but the thing is අර වා හැමදේම වත් එක්ක වා වුණ කරා. අනිත් අත් එක්ක compare කරනවා නම් නැහැ ගලවන්න කියන්නේ. right? If you are better today than yourself yesterday, right? That's an improvement, right? You have gone already, right? You can continue කරන්න දෙන්න for these 28 days also, right? It was a part of මේක අර අසල් ඉවර කරන්න පුළුවන් without any regrets. Regrets කියන එක තියාගන්න එපා. like එක break down වෙන අවුල්. Arius regrets තියාගන්න එපා. වෙන අවුල් එක. right? ඉතින් මේක තමයි investment එක. ඔබ to invest on time these days, right? වෙන මොකක් කිසිම දෙයක් කරන්න එපා. ඉතින් 28 days do invest in your time and work hard, right? So we will contact if anything. All right, then we'll wind up. Oh. right, we'll wind up. And yes, work hard, go there. And stay safe. See you in the next class, right? Others here, right? Others are there. May or paper discussion never get online sessions වැඩේ ඒවා බලලා ඒ updates channels වලින් ගන්නවද මොකද මාත් සමහර දේවල් quickly දාන්නේ අද හිතනවා හෙට දාන්න වගේ සමහර දේවල් time set right ඒ නිසා මේ ඒ updates channels වලින් ගන්න හරි අද decide කරලා හෙට දාන්න පුළුවන් මම ඒ වගේ support channel එකකට එහෙමයි කියලා last week right මම ඒක decide කරලා ඉන්න නැහැ ඊට පස්සේ මට time access ලා මම right so likewise do Right? Question is just you have go on there on. Is Java stay updated, stay connected, and that doesn't mean uh, sticking to the phone, right? Phone එක තියාගෙන නෙවෙයි. Update එක කියන්නේ මම දැන් දාන්නේ දැන් ඉන්නේ කියලා. තාමත් කරලා ඉතෝම දානවනේ. Phone එකේ පොඩි වෙලාවක notifications set කරන්න. And it's better if you can turn on notifications while you study. Right? Notifications තමයි phone වල case එක. Right? Notification එක ආවතාවට බලන්න ඉතින් නේද? Notifications off කරන්න. phone එක නම් off කරන්න ඕනේ නැහැ. Notifications off කරනවා. ඒ do not disturb phone එක නම් මම දන්නවා. අන්න එකක් දාන්න ඒවා use කරන්න. ඒක මිනිස්සුන්ට use කරන්න කිව්වා. අර නැත්නම් do not disturb දාන්න නැත්නම් all right then. Right. Then right. Then go there. See you in the next class. Right. Goodbye.